Wow, StreamYard is like super fast today. It went live right when I actually pushed the button. I'm not used to that. Anyway, I'm Brent Leary. This is not a CRM Players event because the Venerable Paul Greenberg won't be able to join us, but it is a PPN watch party because we've got folks that are hosts on other shows that'll be joining me. And we also have special segment, guest segment. They're not really hosts, but they're the focus of a segment. Anyway, we are here because for the first time, it feels like folks in our industry are really going to have to start paying attention to another AI kind of hardware company other than NVIDIA, because AMD seems to be making its presence felt in what we usually kind of talk about and discuss. So we're going to actually check out the opening keynote together with the crew. But before I bring them out and before we do that, I wanted to do a couple of quick, I think it's housekeeping. I don't know. I always get that wrong. Anyway, next Tuesday, the crew. That is the Crunch crew. The Crunch crew. I kind of like that. The Crunch crew. Dave Smith and Rebecca Wettemann, and actually Patrick and Biscuit are probably maybe make an appearance there. They're going to do a summer wrap-up. Wow, it's already time to do summer wrap-ups. It's kind of depressing when you think about it, but their conversation definitely won't be. So look forward to that. That's next Tuesday, noon Eastern. And then market calendars for August 6th. We're going to be basically dedicating, and this is a players show. We're going to be dedicating the whole episode to Zoho at 30 years. Zoho has actually been around for 30 years. And I think I've known them for at least 20 of those 30 years. It's kind of amazing to a certain extent because they have done things so counter to what we're used to in the tech industry. And it's been to their extreme benefit that they have stuck to their guns, done things the way they have done them. And that's probably why they're not only around 30 years later, but thriving 30 years later. So we're going to have Raju Vagesna join us. He is their chief evangelist. But if you know anything about Zoho, that's like one of the things he does. He does pretty much. He does it all. So he's going to join us, and we're going to talk about not just the past and the present of what Zoho has done over that course of 30 years, but we're actually going to see what they're going to be doing at 30, 40, 50 years, because knowing them, they've already got a plan for that. So that's 2 weeks from today, 3 o'clock. All right, let's talk about today. So I have to admit, I have been paying attention to AMD for the last 3 or 4 years. I am a shareholder, a very, very, very small shareholder of both NVIDIA and AMD. So I've been kind of looking at them for a while. But this year, last year was the first year we actually started doing watch parties around NVIDIA's GTC event. And so this is actually the first time we're going to be doing a watch party for AMD. And basically one of the reasons is look at that chart. Their stock price is taken off this year. And so I actually did a quick question to Gemini, I guess, to say, well, why has it gone so big already this year? And I want you to pay attention to that fourth point that says 4, SaaS and CRM dependency. So that was I was like, okay, they're already making a name. They're making a stand. And this year they have definitely become a big part of what we do and what we cover. Actually, this silicon for the next generation enterprise, CRM and CX. Now, I think they're talking generally speaking about enterprise apps, but I, of course, I'm looking at CRM and CX, and I'll be glad to share these slides. I don't want to spend too much time on them, but this talks about why AMD is important to CRM and CX. And it's something that they're actually making a name in terms of competing with NVIDIA. And they do things a little differently. You can check out the slide, but So all that added up. That's why we're here. So let me bring on the folks because I think we're all kind of curious about what we're going to see and how it really will impact us. So let me bring out the co-host of the Crunch, Mr. David Smith and Rebecca Wettemann. You know what? As soon as I did that, the music for the keynote started. I don't know if you can hear it because I'm not sharing it yet.
We can.
Let me do this. Let me share this so we don't miss anything. All right, can you hear it now?
Mm-hmm.
All right. So we'll all keep an eye out for this. So first of all, thank you guys. This is short notice because we really weren't planning on doing this until yesterday. And then of course, when it comes to AI with CRM players going back about 15, almost 20 years, our go-to person has always been Dr. Michael Wu. So thank you for joining us. He's also taking the lid off of AI segment on CRM players. So if we're gonna watch AMD or NVIDIA keynote, who better to have on with us than we just call Mr. AI. So thanks, Michael, for joining us. So before they get started, I want to ask you guys each, what are you looking for? I mean, I know for me and Dave and Rebecca, I think Rebecca, I don't think we've ever really focused a hell of a lot on a company like AMD before, but it feels like it's time to start. But what do you guys think? Rebecca, why don't you go first?
Yeah, I mean, I think chips, the hardware stuff is becoming much more important as we think about kind of AI moving forward. So interesting to see how they're positioning against NVIDIA. You know, obviously they have the big partnership with Anthropic, so I'm sure they'll talk about that as well.
Dave?
Yeah, I mean, for me, why am I on the chip keynote, right? I don't cover silicon, but I think what we all do now, especially in software, we all cover what silicon makes possible, right? So I think every promise that software vendor made this year about AI agents is a bet on compute getting cheaper and faster. So I think this keynote, I'm trying to figure out where we find out if that bet pays off. So interested to kind of see what they say here.
And of course, Michael, this is you. This is right up your alley. We wanted to get your take on what you hear. So what are you looking to hear today?
I think what I'm really looking for is, I mean, everybody's saying that they're gonna make agentic workflow faster, and therefore better customer experience, right? My question is always how they're gonna do that. I mean, sometimes, why is AMD make a chip or NVIDIA make a chip? Why does it why is it better to using AMD chip versus NVIDIA or vice versa? Kind of how I mean you can make those claims, but the question is I mean, if you don't have a kind of reason to understand why is it better, why is it a defensible mode, right? Then anybody who comes up with a faster chip is going to displace you. So.
Cool. I'm just making sure I got the right. It says welcome, so I'm assuming. I hope they're not running late, or I'm on the wrong the wrong stream here. So I'm just gonna make a quick. All right, it says it's live. Well, it's still saying the same thing. So I guess they're running a little late, which is pretty much standard for any tech conference. So we'll see.
Somewhere I read it started at 12:30, so we may have a few minutes.
Oh, you know what? You're right. They just started playing the music a little early. Okay. All right. So Lisa Su, I've never heard her speak before. Have you? Anybody actually heard her speak?
Just on YouTube.
I have.
What should we be looking out for, Michael?
She's very technical.
Okay.
She actually knows, not just writing the software to build the chips. She actually knows how to the manufacturing process and everything. So, yeah.
So she's gonna be well. Okay, I'm interested, really, because they seem to have taken a big step up this year for some reason, and the impact it's having on enterprise applications and hyperscalers.
Mm. Yeah, I think a lot of it. Maybe I'll make a quick comment here. I feel like there's just a lot of unmet demand, for faster or just chips in general. And I think that like as the premium kind of NVIDIA chips got bought up. Yeah, I mean, I think there's still additional demand that are unmet. I think their part of their meteoric rise is due to the fact that they just fill that void. They're natural, kind of not the number one, but the next, they're pretty good. They're not the top, but very able to take that, the next best, right? Kind of if you cannot pay for the best, or they're just completely out of stock, right? What do? You buy the next best you can, and they fill that void, right? When you have a demand that you could fill that void, you address this market. That's yeah, and I think that's where I feel like a lot of their stock price and everything, I felt is largely due to that.
Dave and Rebecca, we talk a lot to these enterprise application companies, vendors, and they always talk about the being the biggest and the best.
Yeah.
But how do they? I mean, right now we all know NVIDIA is the biggest and the best in this space.
Yeah.
But how do enterprise application vendors use or integrate something that might not be considered the best into something that's very important to their customer base, which is figuring out how to use AI effectively and efficiently?
Yeah, I mean, I think we've probably spent the past few years talking about which AI is the smartest, like to what you're alluding to, but no one, now we're starting to talk about more about, okay, what's the cost to run the thing, right? And so I think what I'm looking for, I think NVIDIA probably represents a bit of lock-in, the big guys on the block. So interesting to hear what AMD is saying here, and how they sort of go with their open type model. So hopefully she goes there, and we'll see what she's talking about, Lisa.
Yeah, I mean, it's all about, can I lock in chips, and what chips can I get to drive efficiency of AI, right? Knowing that customers moving forward are not going to be just looking at how many tokens do I run through, but what's the value of those tokens?
Do you have any idea? Because I don't know specifically, but when you talk to NVIDIA, they're kind of wide in the kind of use cases and the customers and the situations that they're focused on. But we do know that enterprise software is a pretty critical customer base. How do you think AMD looks at enterprise software? Is that a big, huge target, do you think? Or are they trying to go in another direction, or focus on things that aren't as important to like an NVIDIA who already has a foot in the door?
Yeah, well, I think we'll probably see that depending on who they bring on stage. So if you see a bunch of hyperscalers, probably not. But if you see,
we know who he's not. We're not going to see is Jensen's not going to be a part of this keynote. I don't think.
Yeah, exactly.
They are family, right? So
yeah, I heard they were family, but is that kind of amazing?
Jensen is Lisa's like uncle. I think it's in terms of relative. Yeah. So,
and yet, and still, they built these. Well, yeah, they built these two companies that are competing in probably the most important technology has been in decades. That's kind of amazing when you think about it.
I just wonder if Lisa will sell her jacket at Sotheby's after.
They're not that close of a family. They're both Taiwanese. Same as me. So I'm Taiwanese too. So.
They're not that close of a family. Okay, yeah. That's an interesting kind of side tale to this whole situation. They're family. It's kind of like I think it was Satya from Microsoft and Shantanu from Adobe. They went to high school together or something like that.
Really?
Yeah.
Wow.
Yeah. It's amazing. Like, there's only these handful of companies that are like rolling the technology world, and there seem to be all these intersections and things that really make a little bit more intriguing how this stuff goes on.
Small world.
Yeah. All right. Let's see. We're at 12:30, so let's see how close they are to. Oh, the music is going off. Nope. Not yet. All right. I'm just overall just curious. I don't have any real expectations for because I just don't know what I'm going to see. I don't know what I'm going to hear. So I don't.
Brent,
Yeah.
How do you want us to comment? Just, I mean, because I know the keynote is going to go on.
Yeah.
Do we just kind of jump in and talk
Yep.
over it, or?
Absolutely. You'll see from the old pros, they'll be jumping all over it. I'll be jumping all over it. So yeah, get in if something makes an immediate impact or you want to talk about it. Yeah, feel free. As Paul calls it, what is that? Something Science Theater 3000 or
Mystery
something like
Science Theater 3000. Yes.
Yeah, where you just see like the back of their heads looking at the big screen and they're just talking throughout the whole thing. So
Oh, forward-looking statement.
Oh, here we go.
yeah, we're that's not bad. 12:31, that isn't bad. All right.
Pretty sharp.
Yeah.
The next wave of AI is here, evolving beyond thinking to acting, and it's bigger than anyone imagined, except AMD. We recognize this agentic era would require the highest performing GPUs and CPUs working together. So we're the only ones who build both. It's how agentic AI moves from answers to action, pushing inference compute to tremendous scale. Like an agent that frees thousands of employees from smaller tasks to focus on bigger things. A car that safely handles a new city like a local on its first day there.
This looks like something I saw in the NVIDIA opening.
That pinpoints a disease in millions of cells, then designs a cure. We've built more AI computing power into a single data center than existed on Earth a decade ago. And now, we're giving you the tools. So together, we advance AI.
Not as flashy as the NVIDIA opening, but it's still nice.
Good morning. That's a pretty good morning. I'll try one more. Good morning. And welcome to Advancing AI 2026. It's so great to be back here in San Francisco and to see so many friends and partners and customers, and especially all the developers that are here with us today. And I want to say a big welcome to everyone who's joining us online from around the world. This is my absolute favorite event of the year. It's where we bring the entire AI ecosystem together to show what we've been building and where we're going next. And this year, this is our biggest show ever because we have so much to tell you. So let's go ahead and get started.
No nonsense approach here.
AMD, our mission is to push the boundaries of high performance in AI computing to help solve the world's most important challenges. And I often say AI is the most important technology of the last 50 years. And frankly, the progress that we're seeing in the industry is just incredible. Like every month, every few months, we see something new that was far beyond our imagination. And you can already see the impact across every industry. In healthcare, AI is helping researchers identify new drug candidates faster. In science, we're solving problems that we didn't think were possible a few years ago. And across every industry, AI is changing the way we get work done. And the most important thing is we're still in the very, very early innings of what's possible. Now, just take a look at some of these charts. We look at these every year, and you kind of see the rate and pace of AI growth. A couple of years ago, we were just starting. People were experimenting with chatbots, and it was really cool. But if you look at today, we're really seeing more than 35 quadrillion tokens consumed every single month. That's an increase of nearly 160 times in just 2 years. And that curve is actually just getting steeper. You're going to hear a lot about that today. So just looking at, where's all that demand? I mean, obviously, training remains incredibly important and foundational. And over the last 4 or 5 years, we see the compute that's used for training advanced models continuing to increase by, let's call it, roughly 5x every year. And those models are getting better. Like, we're all experiencing that. We're seeing better reasoning. We're seeing new capabilities. We're now seeing a growing number of specialized models. And one of the things that I really believe in is there is no one perfect model. I think we're all going to use a slew of different models, depending on what task you're trying to solve and which industry you're in. But the bigger shift is actually in inference. And we expected this. We expected that inference would grow faster than training. And we can say that in 2026, for the first time, the world is using more AI compute to run models than to train them. And we've seen that to a point where we think this year, roughly 60% of the global AI compute capacity will be used for inference.
So this is a talk track. I think we have to pay attention to.
It's actually pretty simple.
That's what.
Yeah.
As billions of people every day use AI, the workload shifts from building models to putting them to work. And actually, we're going to talk a lot today about agentic AI, and that's accelerating the shift even faster. So if you think about all of this, we see agents as the next big step for AI. And the most interesting thing is, this is really just started accelerating over the last, I would say, 5 or 6 months this year.
Mm-hmm.
So when we started with LLMs, they were great to answer questions. But we found that to really get the power of AI, you want agents to be able to really answer full questions. So you give it a goal, it keeps working until it solved the problem. And what that means for us in the compute industry, it means that compute demand is growing at an incredible pace. We're actually seeing a step change in compute demand. Because when you ask the agent to do something, it actually has dozens of steps, and it has to reason, and it has to call tools.
Yeah, Intel is up too, not quite like they are, but
keep doing it over and over until it solved the problem. And so you need lots of GPUs to do all that reasoning. But importantly, you also need a lot of CPUs to orchestrate every step around.
They got them both.
So when you look at just what that means from a market standpoint, it's really hard to put this market data up, because I feel like every few months we're changing, sort of the perspective based on what our customers are saying. But what we're seeing is that the shift to agentic AI is certainly growing the AI accelerator market very significantly.
1.4 trillion.
It was actually last year at this event that we called the AI accelerator market at about 500 billion by 2028. And at that time, it actually felt like a very big number. Didn't you think it was a big number? But honestly, you look at it today and it looks conservative. Because the AI demand is just continuing to accelerate. And you can see it, right? Better models, more usage requires more compute, and more compute actually builds better models. So we're now expecting that by 2030, the AI accelerator market is going to reach about 1.4 trillion by 2030. So what do you think about that? Is that a big number?
So that's a 3x number in less than 5 years?
I mean, what that means is by the end of the decade, the AI accelerator market is going to approach the size of the entire semiconductor market today. And although there will be many different types of accelerators, I'm a big believer in there's no one size fits all as it comes to chips. We do expect that GPUs are going to make up the vast majority of that market, because the algorithms are still very much in their infancy, and we're still continuing to see the workloads change. And that favors programmability in the overall silicon ecosystem. Now, perhaps the most—
I wonder if all the data center flack
6 months
is going to slow this stuff down a little bit.
What we're actually seeing is agentic AI is creating an entirely new growth vector for server CPUs. Now, I've updated this number a lot also over the last 6 to 8 months. But look, we call it like we see it. And we were early. I mean, we saw from our largest hyperscale customers, and you're going to see some of them here today, who said, look, as AI inference is going up, we need more server CPUs. And so we saw growth in the server CPU market. And we said, last year we thought it might grow, let's call it 18 to 20% CAGR to an overall market size of 60 billion. But frankly, what we're seeing is that the rate and pace of agentic AI adoption is much, much faster than any of us thought. So we're talking about agents going from millions to billions. Like, we're able to increase all of our productivity, and that requires a tremendous amount of CPU infrastructure. And every customer conversation is telling us that this build out is just beginning. So based on what we're seeing today, and we're going to talk more about how agentic AI is evolving with CPUs, we now expect
something I wanted to comment is that,
to
like,
grow by over
the
50%
agentic workflow,
to over
agentic
200
workload
billion by 2030.
has more
Let's
dependent
start from
on
today,
the CPU.
a $25 billion market going to over
language
200
model
billion.
depends more on
So there's a lot of
GPU, because they're just doing the
about
same
GPUs,
computation over and
as
over
well.
again. Right?
Yeah.
Whereas
Now,
the agentic workflow,
Influence
everybody's
one
trying to do
thing
different
that-
things.
AI
Is
agent.
differentiating AMD in how we think about the market is this
Yeah,
is not
these numbers
just
are
a data center
like
market.
ridiculously big,
As
and
AI
yet we're still
becomes a
talking
larger
about
part of our
people
daily lives,
questioning
we want
the size of the
intelligence to
investment
run
because they don't see how
right
they
where
can
it matters.
actually get a return
And
on that
means
investment yet.
cloud is super
So
Yeah.
these numbers are big, but I don't know
Every day
if
are
these
gonna
numbers are
be
going to be
extremely
reached in these
important.
timeframes
And that's
because
what we're gonna do a lot more
are they
in AI as
factoring in
well.
this AI
Autonomous machines that
apocalypse
sense
kind of thing into these numbers?
And we
Yeah,
really
I think what she's pushing, from what I'm gathering, she's pushing inference,
and
right?
that's
And
exactly
so
what we're focused on at
inference
AMD.
cost is I guess
So
what
putting
buyers
all
kind
of
of
that
care about, that
together,
cost
we
per
actually
token, not
expect that the
ecosystem.
market for high performance and adaptive computing
Yeah, but
products
these
to grow
it still is
roughly
billions upon
40%
billions of
CAGR
dollars
over the
being
next several
invested in
years,
without any
approaching a $2
sign of
trillion
ROI
market
yet.
by 2030.
That's
Oh
like
no, yeah. I mean,
Yeah.
The only way you're going to be able to service a market like that is for us.
Well,
to
I
work
think
together
there's
as an ecosystem.
a difference
There's no one
between
company that can solve it all. But
whether you can
this is
quantify the ROI
opportunity
or
to
there is
bring
an
the
ROI.
best
Right?
and brightest
Mm.
together.
I think there is no
We've
doubt
never
that
been in a better
these
position
agentic
to
AI
lead. We have
has some
the broadest
benefit.
product portfolio.
Right? There is
We have
benefit.
the strongest
It's
roadmaps we've ever
not
had.
easily
And
quantifiable.
the thing that I'm most proud of
and there's
is
two
we have
things.
the
It's hard
deepest
to quantify.
partnerships with the
And then
companies
the
that are
second
building
thing
this
is
future.
that it's also quite expensive. Right?
So
I think there's
a little
some
bit about our strategy.
the ROI
I think we've been very
may not
consistent.
be positive.
We talked about
right?
our multi-year
because
strategy,
they're not using
and it's
it
really
in a way
built
that's
around
effective.
three priorities.
And that's where I
The
think
first is just
a
compute
company like
leadership.
AMD
We're building the
can make a huge
broadest set of
difference because
compute
they can
engines in
actually
the
lower the
industry
cost
so that we have the
per
right compute for the
token
right
of inference, right? So,
Second, it's going to be about
so
open
it create the
platforms.
ROI,
We
make the
want
ROI
everyone
more
to come together in
positive.
an open ecosystem. We believe an open ecosystem is essential to the future of AI, and that's how we get the force multiplier of everyone coming together. And that's open on hardware, in terms of hardware standards, as well
talking
as
about open
software.
versus the CUDA.
And that's why we're investing so
ecosystem.
heavily in our ROCm software. And you're going to see that AI has been a tremendous multiplier in this rate and pace of progress that we're making in ROCm and in software. And it really means that if we put all of this together, we can have our customers deploy on AMD hardware faster than ever. And the third piece is we're going to get a chance to talk to you about powering AI everywhere. So that's AI
Local
enterprise, that's AI at the PC, that's AI in the physical world. And that's adding new capabilities across all of our products. So today you're going to see all of that in action. We're going to start with compute for the agentic era. I'm going to show you a lot of hardware, and then we're going to talk about some software and then our overall products from a platform standpoint. And we're honored to have some really special guests that are going to join us to really help bring the technology to life. So let's start with the data center. Today, AMD EPYC runs on the most important workloads in the world. We power the largest cloud providers. We power the digital platforms that billions of people use every day, and the most important critical systems that are used by the largest businesses, including more than 60% of the Fortune 100 are using AMD EPYC. And that momentum is just building. Last quarter, we reached a record 46% revenue share in the server market, and we're continuing to see every major customer move more workloads to EPYC. And on the GPU side, our Instinct adoption has also accelerated.
You don't want to cover her face up
anymore. We have a broad set of
anymore.
customers across the largest AI labs, cloud providers, leading AI startups, as well as some of the national labs and sovereign AI opportunities are being built on AMD Instinct, and we really appreciate that opportunity. Now, AI compute's becoming a lot more complicated. And what we're seeing with frontier AI is it's really raising the bar for what infrastructure needs to do. It takes more than a single chip or a single server. You actually have to design the entire rack as one system. And that requires leading CPUs, that requires leading GPUs, that requires high-speed networking that connects everything inside the rack and across the data center. And just as importantly, this is about making these systems super easy to use. And so they need to be easy to deploy, easy to service, and very reliable. And that is exactly what we built with Helios. So today, I'm super excited to launch Helios, the industry's highest performance AI rack.
Little excitement in there for the folks.
Now, Helios is built to train and run the most demanding frontier models in the world at massive scale. And I have a lot of show and tell for you. So for those of you who know me, you know that I love holding up chips.
So did Jensen. It must run in the
I call
family.
myself sometimes the Vanna White of chips. But it turns out with Helios, there are lots and lots of components. And so you can see these are the chips inside the Helios rack. These are the
That's pretty
Instinct.
massive.
Thank you.
Yeah, but
That's a,
So this is Instinct, Epic, and then the Pensando chips for networking that are inside each rack. And every one of these chips is part of the system.
how many chips are in a rack?
MI455 is the engine. It's the highest performance GPU in the
probably
industry.
thousands.
Venice, which drives it, is the world's fastest CPU cores. And Pensando DPUs actually, and NICs actually connect them with leadership programmability and scale out.
This show and
bandwidth.
tell.
So I have a few more props to show you. Let's kind of take a look at how these things fit into the overall system. So first, this is now the MI455 accelerator, which is mounted on what we call an enhanced accelerator module, or EAM.
I now see the family
It's a
resemblance and
module that
mannerisms.
goes into Helios, and it is much more than the GPU package.
And the passion that they have for this stuff.
It's GPU, memory, power delivery, high-speed interfaces, system management, cold plates for liquid cooling, all into one compact serviceable module.
Wow.
Pretty cool, right?
Look at that memory
Now,
bandwidth,
let's give you some
23.3
specs.
terabytes
We're
per
talking
second.
about 320
It's amazing.
billion transistors. This is built with TSMC's leading 2 nanometer and 3 nanometer process technology. And most importantly, it brings together nearly a decade of AMD chiplet innovation. So it allows us to combine 12 compute and IO chiplets with 432 gigabytes of memory, all connected by leading industry 3D chip stack packaging. And I can say for sure, it's the highest performance AI accelerator in the industry.
It's such a polite audience.
Yeah, I mean, so she's kind of
This
going
is the
at the
CPU board
infinity thing though,
that's
because if they're
inside
leaving
Helios
on
compute
chip,
tray.
she's
And I'm
kind of
going to
leaving
talk a
on
lot
the
about
rack,
CPUs
right?
later.
Mm.
But just to give you a high-level view, it's a high-speed 96-core EPYC processor.
Well, I think if you
DDR3, all
if you
the
start with
IO
the rack,
to feed
it
the
gives you a
GPU
lot more
on a single board.
kind of
And we also
narrative
have
around
our
differentiation.
Selena
Like, 'cause
DPU.
the chips,
Yeah.
This is a
the
critical
chips
part
are
of networking
going to be,
infrastructure.
it's like
And it
a
really
shovel.
allows
Right?
us
I
to
mean,
deliver
how much
both
is a shovel?
front
One
end
shovel
as
different from
well
another
as
shovel.
the scale out and scale
If you talk
across
about like
bandwidth
a
overall.
big kind of tractor,
And
right?
this is our
You're going to
Volcano
have a lot
and
more
NIC.
pieces.
And you can
how you
see,
design and put it
this
together.
actually allows
You have a lot
us
more
to really
differentiation
have
that way,
up to
and
6
that's what they
Volcano
could. I
NICs
think that's
on
why
one
they're
board.
able to
And it
claim
uses the open
that they are going to be better and
so
more
each
efficient
Helios
for
compute tray
agentic
includes 2
workflows.
of these Volcano
Mm.
boards,
Yeah.
and that allows us to have the scale out and scale up networking overall. So you put all that.
That's
inside
probably
there,
why also
and we
NVIDIA
have
bought that one
an
company,
additional 6
Grok,
dedicated networking trays
because
handle the
that was a
scale-up
leader on the
networking.
inference side, and they were
Those
kind
are
of
all connecting
really
separate
focused on the big
IPs
picture
together with
training
UALink
stuff.
Training stuff,
Mm.
yeah.
Yeah.
with silicon
Absolutely.
from our partners. And that's what we mean by an open ecosystem. So when you bring this all together, I
Yeah,
want
but
to
I
say
think
Helios
regardless
is
of whether
simply
you're
the
doing
best
training or
AI rack
inference,
in the world.
it's still going to be GPU bound. It's going to be heavily dependent on GPU. It's the agentic
Now, let's take a look at some
that's
numbers.
more has
Clearly,
more
it's
reliant on the
very
CPU
competitive
side.
world out there.
Yeah, the
when you
broad
compare
training
Helios to
is
the competition,
more GPU, right?
We're delivering
Yeah.
50%
Training and
more
inference are
compute,
both GPU.
50% more HBM.
Because they're doing the same
capacity
type of computation, right?
and 50% more
What's the
neural
CPU.
network.
GPUs for the reasoning
And what that
CPUs
means
to orchestrate?
is that every Helios.
Well, I mean, to think about it, it's
more performance
GPU is
for
very
largest
good at doing the
models,
same computation over and over
capacity
again
for
very
longer
fast. Right?
context,
And
and the
in a
bandwidth
language
scale
model, right, whether
across
you train it or you're
thousands of
using
racks.
it to evaluate
And
that
now
neural
we can
network,
kind
you're
of
just doing
come
the
over
same
here and take
computation.
a look at another very
When
large
you
piece of
train it,
hardware.
you
This
feed
is
forward,
now
and then you
hardware that
do the
customers are
backward
deploying.
propagation,
You
and
can see more
you
of
do that
that
back and
as
forth
you go
over and over
through
again.
the
But when you're doing
these
inference, you only do the feed-forward
and
path.
each one of
right? But it's the
these
same
weighs more than
the
160
computation is very
pounds
similar.
and stands
But
less
when
than
you're
2
doing
inches tall.
agentic type of
That's just
workload,
an
right?
extraordinary
Everybody
amount
is
of
trying to
technology
get
when you
this
look at what's in one
agent
of
to
these
do
trades.
something different.
And when you
So
bring
the
these things
workload is
together,
very different.
numbers are just
Right?
incredible.
Then that's why you need
More
that
than
general
18,000
CPU-like
CDNA GPU compute units,
computation.
over 4,600 Zen 6 CPU cores, and 31 terabytes of HBM4 memory, all in a single rack. That's what it takes to run agentic AI at scale.
You look at stuff like this,
So
and you look at how much
today, I'm excited to
energy
announce that Helios is
and
in
power does
full
it take to
production.
run just one of these things.
Yeah.
And she's talking about this like it's going to be one of billions.
We have
Where are we going to get all this energy to like run all this
cool
stuff?
it. And
Yeah, and cool it. Yeah, I guess going under in the ocean or something. Or
Yeah, so I think the water cooling is
And we're
very
extremely proud
clever,
of the
right?
work
Because
that
you
we've
could do a
done
closed loop
across
water.
the leading
cooling.
AI
There's no
labs
evaporate. You just
Helios.
recycle the water over
And
and over
so
again.
let's start with some of our guests.
So,
Today, I'm excited to be joined by
yeah,
our
power-
newest big partner,
Power-wise,
leaders
it's
in frontier
probably
AI.
an issue.
To
I
share
mean,
more about what we're
thank
doing
God they are
together, please
semiconductor.
welcome
Right? If they were,
Anthropic co-founder and
if
chief
they were,
computer officer, Tom Brown.
if they were conductors, right, it would be like a light bulb. You'd be burning so much energy. But the
Oh, we
fact
got
that
a-
they're semiconductor is actually helpful.
Anthropic.
Yeah.
Hello, Tom.
Yeah, we got Anthropic
Great
on
to
board
have you
here.
And it is really such an honor to be working with Anthropic. We had a big week this week.
Is he that tall or is she that short?
Anthropic
The
has
tall
had,
guy.
incredible success over the last few years. Claude has made such a big impact on the overall industry. Compute is such an important factor in the progress. Can you just talk a little bit about your compute strategy and just how things have been evolving?
Yeah. And first, thank you so much. A hard act to follow with Helios. Amazing.
No, he's a co-founder.
So
Okay.
with Anthropic,
Chief Compute
as
Officer.
you mentioned, the scale of that we're growing.
Do you think that's going to be a thing in our industry? A chief compute officer,
And
like
so we
somebody
have been
responsible for trying to
make sure that we have
handle and discuss and keep an eye on
different chips
what
and
it takes to
use the
the
best chips.
compute and all the energy and all that kind of stuff that's needed?
Yeah, and look,
I think you're onto
I'm not
something.
so
Yeah.
sure.
leading in that area.
All right, so
I'm happy to say
Yeah,
Go ahead, Michael.
I've always wanted to be.
I'm not so sure if you need
The
to.
early times we talked
Right,
as
I
you were
mean,
starting Anthropic.
I
So
think
we
it's
can
abstracted
add the
away at the
CTO,
application
we can
layer.
charge
Right? I
it.
mean, is how,
2
yeah.
gigawatts of Helios.
I think
What was
he's like
the key reason?
concerned with how they allocate compute to do
So I
different
think that
tasks.
with a
But at the end of the
CPO,
day,
it's just Helios
Yeah.
is an amazing.
with a like somebody responsible for compute report to the CTO, because that could, it sounds like that might be a bigger and bigger piece of the puzzle, trying to manage that aspect of all the tech stack.
Whenever we're bringing up a new hardware.
yeah, but is it going to be actual compute that you manage, or you just manage like
So
allocating the workload to different kind of model,
as we were
right?
thinking about this, we
So you're not actually
our,
you're managing
an
compute
operation
through
of MI365.
managing the model.
You
I
guys
think right now
can
there's a
see
lot of
all this
model
traffic
routing
working.
that's going on
And
in,
we expected this to
like,
be kind of
enterprise software. Because if
our
you're asking
experience
an
was
AI to help you write code, you probably want to use
they spun up,
Claude.
they connected
But
it
if you are
to
using
asked it,
to
hey,
answer
bring
some
up this
questions
machine,
about
left it
the
going
market
over
or
the
whatever,
weekend,
something
and we
simpler,
ended up with a
you
graph
could use
of
some
the
something
performance
simpler, right?
bar
Something doesn't
being
not as
all
costly like
just going
OpenAI
up
or
and up
Gemini
and
and so on.
over the
You
weekend.
route the model,
So,
right?
yeah.
But those models are the one that actually sits on top of these compute.
I
Like
think
the
that's
company is gonna
something
optimize them
that you guys
for
have made where
what they do.
that,
But
like anyone, like human
I think that
or AI, can now
at the enterprise
pulse
application
on your
level, they're
Tom, I
probably
kid you not,
abstracted away.
when my team told me that you had an engineer working on MI355,
I wonder too,
said, hey,
if there's some
are we, like, making
significance
sure we help
with
them?
Anthropic
And they're like,
on.
they
I
say they don't
know
need any help. They got it all
OpenAI
covered.
and
And I
Meta
was like,
is
hey,
working with AMD.
that's a wonderful
So are we
story.
seeing
Thank you for
where
that.
people trying to
Now,
diversify?
we're also super
They
excited
expand
about
there,
what we're
outside of
doing
NVIDIA?
because, one of the most valuable parts
I
of
think
this
that's definitely going to be a part of it
is,
eventually.
Claude and using Claude within AMD. Like,
Because
we're
certain
big
things,
believers in the
NVIDIA
fact
is like
that,
the power drill, and sometimes you don't need the power drill to do certain things. And if you could get a cheaper tool to do something, then instead of using, what is it? In your hammer, everything looks like a nail. So
Yeah, exactly. Yeah.
if you can get different tools to handle it that are cost effective, you don't want to use the big power hammer.
Yeah.
Yeah. So what I'm saying is that like, those levels of details are abstracted away at the enterprise application level. Right? Because I mean, you may not even have a choice. Right? I mean, I want to use AMD, but you cannot tell Anthropic that I will buy your compute. I will use Claude, but I will only use your Claude if you run it on AMD
and also on the
and not
software
NVIDIA.
side.
You don't have a choice. We don't have that.
Anthropic's
Like Claude doesn't let us choose
just incredible.
the compute that they
So,
use.
Tom, one of the
Are-
things today
Are vendors that are building out these, they call them the agent studios for building all this stuff, and they're allowing you to use whatever LLM model at a time. Do you think eventually they'll build into their studio capabilities AI that will manage that and just let you kind of focus on the core problem that you need, and let the AI manage what compute, what model, whatever you should be using for that, and how much that's going to cost you?
I think, Brent, eventually we'll get to a point where the AI, it's sort of like Uber, where I can say, like, I want an Uber Black to support this agent, or I'm willing to do a cheaper LLM call.
Yeah.
Toyota for
Yeah.
this one, and kind of meter it that way so that people are thinking about it in terms of what's the value of the agent that I'm trying to build.
One thing now.
So let me put this in a little.
I think we can continue to.
Yeah, let me put this in a little perspective.
Where
Right?
that's a place
So
where now
you can pick Uber Black or Uber,
we can work together
regular
to secure
Uber
things
or
at the chip
Uber
layer,
kind of
server level, the rack, the whole
whatever,
network.
the cheapest version of Uber, right?
Like,
Yeah.
But
not
you
just us,
you
but
don't
the
really have a choice to tell
No, I think you're completely
Uber,
right. We are
like,
super
what
focused
fuel you're gonna
on
use.
the idea of
you don't have that choice.
What battery?
Yeah, or what battery you're gonna use,
whether
right? You
it's,
don't have that
it's
choice.
power,
You- I mean,
software,
you
and
can
security,
use
as you said.
You
So, really,
I want Uber Black, I
huge
want a
thank
regular
you
Uber, or
for Uber
Uber X, right?
the opportunity to
But
work very
what
closely with you and your
The
team. Our
driver
team
choose
loves
to put
working
in
with
their
you guys.
car, right?
And we look
they
forward
of
to
course will
everything that
optimize
we
it
do
for
together.
themselves, right? Because they want to
so
make
much.
money. So basically, every language model, every vendor, right, whether it's OpenAI or Anthropic, they are going to choose
So,
allocate
Tom
their
talked
compute the
about
most
how
effective as
important
possible.
performance
Right?
is,
But
and
we don't have
we
that
have been
choice.
laser
They don't
focused
make
on ensuring that the real world
a
performance
configurable
of
parameter that we can
MI455
control.
and Helios
Until they
really,
do, we
comes
don't
true
really have a choice.
when we
is what
look
I'm saying.
at system results. So let's take a look at some of those results.
And
So
I think,
here's
too,
an
Michael,
example.
most
We're
people
running
don't want to take
DeepSeek
on that
V4
level of
Flash,
choice.
one of the latest
Like, they don't
recent
want to manage
models,
that.
and we are actually comparing.
They just want to get from A to B with as little friction as
And,
possible.
the key thing is with every generation, we want to make huge leaps in performance. So we're seeing that at lower concurrency, that MI455 delivers 4x the throughput of MI355. But clearly what you see with large users,
These naming conventions,
across the board,
jeez.
that you want to increase the number of simultaneous users, you want to increase the amount of work that you can do at the same time. And so at the highest concurrency, we're seeing Helios deliver up to 34 times more throughput than our prior generation.
34 times.
And what that means is more users, much faster response, and much better efficiency at scale. And performance is just one aspect of it, right? The other aspect, and what I should have mentioned when Tom was on stage, is every one of us in the enterprise is seeing our AI budgets go up every single month. Is that right? Are you seeing some of that?
Wow.
And so customers really care about cost per token. And with every generation of Instinct, we're driving the cost per token down. And that's with more memory,
That's where their
more
ROI
bandwidth,
is.
and much more compute. And
But how many tokens do you still have to use, even though the cost per token is going down?
18 times more tokens per dollar. So customers can serve far more users with the same investment. And as you think about how that comes together in a rack, many of our data centers right now are really limited by power. So power is kind of the maximum limiter. And so we tested Helios over a full range of workloads where you have a fixed rack power compared to the competition. And what we're seeing is across the highest throughput workloads, the most interactive applications, all of these leading inference workloads, we're seeing Helios an average of 10 to 15% more performance than the competition. And that comes with all of the system work that we've done in the overall system. And how that translates to a customer is cost. What we expect is the Helios rack delivers more performance, and it also delivers up to 30% more tokens per dollar than the competition. So I think that's a pretty good overall value proposition.
Yeah, it sounds good, but we need some kind of example. How much actual dollars are we talking? Not just the percentage saved, but what's the amount here?
She's talking performance per dollar, but what's the real ROI?
I think that's things that customers are just really irritated by. Mm-hmm. They want these vendors to really give them a more concrete idea of how much this is going to cost.
Yeah, but think about this. I mean,
is OpenAI.
We're not the buyer, right? The enterprise software are not the buyer of these.
Please welcome to the stage OpenAI's head of infrastructure.
Right. So I mean, I think that they are selling it to the inference vendor, the frontier lab, right? So they're going to buy it.
Thank you.
Right?
Thank you, Satya.
So they're to them that's the concern, right?
Most importantly,
I think for the enterprise, we buy inference from OpenAI and Anthropic or whatever. Right? So that's going to be somehow translated, but it's not going to be a one-to-one.
But they have to figure out a way to work with the OpenAIs and the Anthropics to provide a reasonable estimate of how much this stuff is going to cost. That's what's driving people crazy. They use this and then they find out, oh my God, look what I'm getting charged for this. I ran out of my budget in the first day.
Yeah.
They need to have a better understanding of how much is going to, a better realistic ballpark. And it hasn't been presented yet.
So Brent, it's the thing I said before, right? I mean, you don't have a control for that. I mean, you can't tell Claude or say like, okay, I want you to run my inference on AMD hardware for this next question. You could choose like whether I want to use Opus or Sonnet or Haiku or now Fable, right? But that's it. You don't get or high, medium, low effort. That's all you get to choose. You don't get to choose.
I guess what I'm saying though is these companies are working together. We got OpenAI right here with AMD. We just had Anthropic. Mm-hmm. They need to work together to give people an understanding, a ballpark, not just a 30% lower total cost, but something that's a little bit more concrete. I'm not saying you got to hold them to it, but I think people would really value having some more of an idea of what is gonna cost us to do certain things. I'm not saying you got to be extra explicit to the dime, but I mean, come on, you got to give these folks a little bit more to kind of hang their hat on.
Working really closely together. I think it's been a true journey.
Yeah, I think that sort of depends on your task, right? I mean, if you use it to write code,
landmark.
Right, obviously, it's going to take a lot more.
You're going to deploy up to 6
tokens than if you use it to kind of prepare a PowerPoint or write
to actually have
a draft or some essay for you, right?
So, can you talk a little bit about?
I think that this, and in fact, it's not just a little bit different. It's probably orders of magnitude different.
As you mentioned,
writing code will probably take 100 times more token than your daily kind of everyday responding to email, generating images, and so on.
So I totally agree. I'm just saying they need a little bit more guidance as to how much certain things are going to cost them than they're getting right now.
Yeah,
at least that's what I think.
both you guys are right, but I think what we're seeing, that there's this technology gap, right? It's not a technology gap; it's a market maturity gap, and I think that's what Brent's sort of referring to. It's market's not mature enough to really give you that answer.
And the fact that it's such a moving target right now,
Yeah.
right? We're
It
still
is.
figuring out when do I need to do probabilistic versus declarative workflows.
But we can say, like 6 months, a year ago, we weren't even talking about that. Now it's front and center.
Yeah.
And next year we're going to be talking about stuff we never even thought about now.
Yeah.
Because it is moving fast. But the challenge is still, how do you help these vendors, customers feel comfortable about doing certain things with this technology and how much it's going to cost them?
Yeah, and so that's why we saw Zoom the other day talked about outcome-based pricing. So we're going to probably see some interesting pricing models. There's consumption-based, but I think outcome-based may be interesting thing we'll see some of the vendors start to move towards.
I got to do a quick hello. I don't even know. This might be somebody I'm related to.
I don't know. Is that your cousin?
It might be. So hello, maybe because I don't know them. And Christopher is a big friend of the PPN network. The only pricing model that will not stress enterprise budgets will be one based on edge computing, where there's enterprise contribution. The compute required has a scalar impact on monthly billing, removing or at least reducing the need for. I think everything's up for up for discussion at this point.
I think to Dave's points, eventually we've got to get to outcome-based pricing. We've got to have a way to meter that, so it's not a judgment call, but actual metrics.
That I price on interactions, outcome, not the usage. Yeah.
We've seen a company like Pega put up these calculators that at least are moving in the direction of trying to give people a better understanding of what something may cost based on what they're trying to do.
Or like if you look at what Verint did, remember Brent, when they came out with their for their bots, where it was like, we know what the cost of a human doing this is, so let's take a discount on that and price that.
Yeah, I think they got to do more. Vendors in general have to do more of really making their customers feel like a little bit more understanding. Not to say they have to, this is what it's going to be, and then that's that. It's just, I think there's a certain comfort level that you have to give their customers to feel even better about trying and using a lot of this stuff. Like you said, Rebecca, you talk about fear of messing up. I think there is a huge fear of messing up when you hear things like people's databases getting completely wiped out or running through your budget within like a couple of days. People are afraid of that kind of stuff.
Well, and I think the other thing too is, if I think about the CX world, like if I'm the contact center champion, I now have to go up against whoever runs CRM and whoever runs ITSM, because we're all competing to have our agent run on our platform of choice.
Yeah.
If I'm the champion for contact center, I got to be able to articulate really, really clearly why my approach is highly valued, better outcome approach than the IT service management guy or the CRM.
In a data center, so the whole data center.
This whole AI anxiety thing is real. And despite what some people say, it has to be addressed a little bit better than it has been. And I'm talking about just the industry, not any particular vendor. The industry has to have a better way to talk about this to their customers.
These are all intertwined, and they all have to be co-designed. And one of
sorry that we just talked completely over the OpenAI
guy. How easy and productive it is for us to work with you and give you insight into how we expect the world to change in the future.
How much do you think CRM, CX, or enterprise applications in general are driving any of this discussion that we just had? Michael, what do you think? Because this is really
like I think it's too many layers kind of abstraction away. I feel like it's not.
Yeah.
I mean, you're talking about like like I said, you're talking about people want to get from A to B with Uber. You're talking about the fuel. right, that they're talking about, they put in the car,
to actually
or even to a lower level, like what kind of tire they use.
That's
If I use a certain tire, I could be more
really
efficient.
do
Or
recognize
if I
that
use
input is so valuable.
a
So I have to
tire
say,
with more traction,
thank you
or
again for just the
with bigger
extraordinary
tire or
partnership,
something like
the amount of work that our
they
joint
do
teams
make a
doing
difference.
together.
But I
And
don't
we
think
couldn't be more excited about the
it's
opportunities
something that
in front of us.
the
Thank you so much.
buyer of enterprise or CX or CRM software can control, right? The only thing where that becomes real and where they can
to the
control
world of
is
CPUs.
if they actually
There's been a lot
have
of talk about
a
CPUs recently,
local
and I
kind
can
of
say that this has been the
version
foundation
of
of
the language
our
model.
AMD data
If they
center
run a
strategy
local
for a long
LLM,
time.
right? If
We
they
want
have their
Epic
own
to get
LLM, they run it locally,
And we've
then they
been
could buy their own
very, very
silicon
clear
to
mission.
run those.
Every generation,
More
more performance,
if
more
you are
efficiency,
relying on
more
OpenAI or
capability
Gemini or some
for a wider range of
cloud,
workloads. Now, Naples was our
vendor,
first generation.
then you don't have a control
established the
of what
foundation.
hardware they use.
But Rome and
They will
Milan really
obviously have an
changed the
interest to
economics of
optimize
the
it
data center.
themselves.
We did more
It's not
than
up to our
people
control.
expected in terms of adding core count and adding
One of the things that would
And
be
in turn,
a marker
expanded our
when I think
performance,
about the
in turn
NVIDIA
set the new bar
GTC
for
conferences,
density, throughput,
they've actually had a Bill McDermott right on
That's
stage,
really
you
big.
know, representing the enterprise application
roadmap
space.
and very
I
specific
bet there's not going to be anybody that's
and leadership
at that
actually
level
grows
here.
with
I
every
think we're still
generation.
like you, Michael. I think you're
This is why
right. They're still
today,
operating
5th gen Epic
at the
Drive
lower
is
levels.
best
They're not
server
getting up
CPU
to the application level
Yeah.
yet.
up to
And
192
that's what I was saying before. Like, we'll see who they bring on stage, right? It will give us an idea of where they're where they're heading here.
I mean, even if like NVIDIA bring Bill on stage, I don't think there's anything that ServiceNow as a platform would enable people to control, like
and
what
that's exactly what
NVIDIA chip
that's
or
for.
they gonna actually use, or
There's been a lot of talk
or the
about it,
trade-off between
but it's
NVIDIA
actually
chip
a very
versus
new
AMD
field.
chip on
And what we
a
see
ServiceNow
is
platform.
that
No,
server
but
computing is
it does talk
actually
about, I think,
across a couple of
the
different
importance, or
workloads.
even if it's down the
So
line, the
first
importance of
section is
enterprise
CPU
apps
servers.
on top
And
of
that's
all
fairly
that
well
stuff, and
known.
what they
That's
need to
where
be done in
CPU's
order
job-
for it to work for
the
their
CPU's
customers.
job
Yeah.
is basically to drive
Yeah, and that's to
And so
like
the
Rebecca's
job
point
there
before, like that's
all
key. Like
about
you talk about, there
we
you have
want
a
the
bunch of
highest
different
frequency
departments
cores.
all vying
We want the
for
fastest
compute.
IO.
You
We
know,
want
whether
to
it's
keep the
CRM,
GPUs fully
ITSM
fit.
guys, and so
Now, the biggest
so
middle part, this is the
some
largest
sort of
growth,
context
is
layer
actually
there
agent
to make
servers,
sense
or
of all
what
that.
we call
Because
agent
if you address the
sandboxes.
same customer multiple times,
And this is actually a
not
whole new class of workload.
context layer. So
Here,
that's
you
how you sort
execute code,
factor that in.
you actually call a bunch of tools, you actually query data that's outside the model, you have a whole bunch of things around it. And in this place, the priority is actually density. So we want the highest performing cores per watt to run thousands of agents at once. And then we have our traditional general purpose servers that run the enterprise. And here you're going to have a diversity of
Agent
workloads.
CPUs.
It's all about efficiency. It's running the applications. It's running databases. It's running data services. And all of that is what we would traditionally say is general purpose server. And so with these different workloads, you actually need the right CPU for the right workload. And Epic is the only CPU portfolio that leads across all three. So Venice is our newest and most advanced server CPU family, and it's actually designed for the agentic era. We're extending Turin's leadership across every single metric. That is performance, that's efficiency, that's TCO for cloud, that's enterprise efficiency, that's HPC workloads. And Venice starts with our all-new Zen 6 core. We have higher IPC, higher frequency, and that delivers up to 1.8 times more performance than Turin. That is one of the largest generational gains. I mean, we have been doing this for 6 generations, but this is one of the largest generational gains in the history of Epic. It's 203 billion transistors built on TSMC's newest 2-nanometer process, and it uses a next generation chiplet that supports up to 512 threads per socket. And this is actually a really important point. I'm going to show you why in a few minutes.
I mean, she's so technical.
I was getting ready to say, she is completely lost me at this
to double the memory and the I/O bandwidth.
It's hardware
I have
specs
a few more chips to
she
show
knows
you,
our hardware specs
if that's
really
all
well.
right. And what's clear is Venice is not one chip. Venice is actually an entire family of chips. And this is where our chiplet architecture becomes a huge, huge advantage. It lets us
You
take
see
the
how their
Zen 6
stock price
architecture
is
and build
changing
a whole
if it has
portfolio
during the
around it.
course of this.
So let's start
discussion.
with this guy.
Let's see.
This is Venice HF. This is the
Yeesh.
highest performing CPU.
Down 3.5%
that
right now.
drives AI host nodes.
Yeah.
It has
But everything's
two
down. So.
chiplets, each with 12 cores, running at up to 5 gigahertz with the I/O and memory bandwidth to keep the GPUs completely fed. And this is the CPU that I showed you before, shipping inside Helios.
This is still basically an engineering kind of conference.
Now,
And I don't think it's not
This
just
is
any
its
engineering, it's
bigger brother.
hardware engineering.
it's
It's not
Venice
even a
chip
software
64.
engineering.
Oh,
It's
yeah.
a hardware
This is
engineering.
that's
Yeah,
built
you're right.
for agentic sandboxes.
That's why I'm saying
It
it's a
also
little bit,
has 8
it's
compute
several
chiplets,
layers
But each of the chiplets
away
now has
from
32
these,
cores. So it
the
scales
enterprise
all the way to
software
512
that
threads.
we often
And it is
deal with.
the highest compute
Yeah,
density
you're
in
right.
the industry.
But it's so impacting and will impact even more and more.
Yes,
Customers
That-
get more
they
agent
do.
capacity.
Yeah.
but like I said, it will impact it. But
per rep
if,
or not.
like I said, if the user cannot have any
Okay,
control
then
over it,
one more member of the family.
it's
This one
basically
is the
doesn't matter.
Venice
Right?
128 core.
We just have to
and this
believe
guy is
that
optimized for
the
enterprise and general
vendors
purpose
to
servers.
of the language
This
model
is
is
the
going
same
to optimize
leadership
it
performance
so
per
that they
core,
could,
but it's in a
make the
lower
most
cost,
profit,
low power design
and
for
therefore
enterprise
to sell it to
applications.
the enterprise software
And
who's
this
going
one
to
is
use
really
those language
tuned
models
to give customers the best
more
performance per
effectively,
dollar
and therefore
across a wide
benefits
range of
us or
configurations.
the
You can
enterprise who
see
use those enterprise
really
software.
the power of the
So
family.
it's several
that they
layers.
come together.
It is, but you know,
In addition
just
with
kind
you
of
guys,
thinking
I can
back,
tell you that next year
I
we're
think it
adding
was
a
about
few other
2 or
chips
3
in there.
years ago
We're
where
adding Verano, which is the next
Jensen
generation
was
for
on
AI
with
host
Bill
nodes.
McDermott
And what
at
that
Service
adds is
Knowledge.
a more power efficient, low power
And
memory, as
why
well
do you
as
think
a
that
interconnect
that
between the
they
CPU and
started a
GPU.
relationship that
And then we're also
far
adding
back,
for our high
and
performance
AMD
computing,
is
our technical
not even
computing,
talking at that level
Venice
yet?
X,
Yeah.
But why do you
using
think
our 3D
at that
cache
at that
stacking
point 3
technology.
years ago, an
So we're really
enterprise software
first to
company
stack
like
memory
ServiceNow
chiplets right
was
below the
building
compute
this pretty
chiplets to
significant
accelerate
relationship
performance
with an
even
NVIDIA
for, those types of
back then?
workloads. So you can see one architecture, a CPU.
I'm not sure. I mean, unless they're,
There are many different types of
gonna,
CPUs. And for
build
us,
some
one
kind of
architecture
language model
spans
that's
dozens of
proprietary
different
or,
chips. And that
um,
breadth is
yeah.
someone that no
I don't think it
other
matters
CPU vendor
to
can
them
match.
because they're
And
not
that's
going to
what makes
expose,
6th gen
like
Epic
I said, the
best
control,
CPU
right?
in the data center.
I mean, they're not going to be, if you buy ServiceNow platform, you cannot configure ServiceNow platform to
Now you're going to
choose
bear with
to
me
use
because I'm going to take
NVIDIA
you
chip
through some
versus AMD
performance
chip.
that the numbers are just
There's
incredible.
no way for
So looking
for
at AI
any
workloads,
enterprise
right? Again,
buyer
you have
to make that
different
configuration.
use cases and
So it
different
doesn't matter,
workloads. Starting first
You can,
with GPU
all
servers.
you can do is I could choose,
Many of the largest frontier
which
models
language model
require
I
you
use.
to
I could
move
choose,
data
I could
between the
use
CPU
model
and the
routing
GPU.
to choose
And in that
between
scenario,
Claude,
Venice moves the data faster than
ChatGPT
the
or
best
Gemini
competitive
or
x86
some
processor,
other cheaper
delivering up to
variant of it.
1.8
right?
times more
That's all you
tickets
can
per
choose.
second. And when you look at
That's still
agentic
one
CPU
level
servers and
above,
sandboxes, because of our
this level,
density,
the
Venice
chip level.
delivers more than
So-
twice the agents per watt for agent sandboxes.
Yeah.
And for general purpose applications,
So
in this
you
case,
take
we're
back to the
standardizing
enterprise
on
apps when the
100
desk come on.
kilowatt. Venice
We're doing
delivers
a
more
wager.
than twice the performance per watt.
Well,
I
like I said, the only time when it
incredible
matters
results.
is if they
And
are going to have
the gap is even wider
their own
if you
kind of
look
language
at
model.
ARM
If they're going to
processors.
run, they
So if you
want
look
to
at
take
the
some
leading
open
ARM
source, right?
processors,
Take like
when we're
Meta,
comparing
Meta's
at
Llama,
the chip level,
which is
Venice
open
supports
source,
up to
and
2.8
they
times more
want to
agents per
run it
watt.
on
And when you look
locally
at the rack
to
level,
serve their
Venice is
their,
delivering up to
their-
3.3
I don't know,
times
to
more
serve the
performance per
entire
watt.
ServiceNow platform.
And what
Right.
that
And
means
they could do that.
is at the
right?
data center
if they
scale,
actually are doing that,
you
then
can just get
they
a lot
can
more
make that.
agents
They
in the same
control
power envelope.
the language model, which is Llama, and they can control which chip they're going to use, right?
Now, there's been a lot of talk about what matters most for agentic AI, with some saying that per core performance under load is the only thing that counts. But that's really only part of the story, because agentic AI actually runs as a distributed platform, and that is across databases and vector stores and orchestration. And all of that has to happen at once. And that requires not just raw speed, but you absolutely need density, efficiency, and per core performance all together. And what I'm happy to say is that Venice leads across every one of them. So when you compare Venice against the highest performing ARM CPU from our competition, EPYC delivers 20% higher per core performance. And when we...
It's like the applause line light went off a little late.
I like that number. And when we pair that with leadership core density, we're delivering
And so to your core question,
more
Brent,
performance at the
those
socket level.
enterprise apps aren't
And so
driving
the
this
main
conversation
point
yet?
is whether the customer
Not at
needs
all.
per core or per socket
Like I
performance,
said, they don't have a choice,
Venice
right?
is the leader.
I mean, if they
And there's
if
one
they
more
make
point that's
that
a
you know,
benchmark doesn't really
a
capture.
configurable parameter
Because
on,
when you think
on
about what agentic AI
on the
is,
enterprise
it's really
kinda
like you're
platform,
adding thousands of
right?
employees
Whether it's
to your
Salesforce
enterprise,
or
to your
ServiceNow
sort of
or
traditional
whatever, right?
workflow.
If they make
And
that
that
configurable,
software enterprises have been
then
running on for
the
years.
user
The
can
truth
choose,
is
right?
that
If they
software
don't make that
runs on
available, then you
x86.
can't.
So
You can't
Venice
choose.
runs all of it.
Then it's
And this is where
basically,
x86 has an
and I don't
advantage.
think they can make
You
it
must have the
available
best
either
performance.
because
You must have the best
they don't
density.
actually control
But
that.
having that software
Right? It's a language model
is
vendor
a
that
big,
controls
big
that.
plus. So customers scale up their agents on the stack that they already
Or
have.
if they want to
And now
build
we're
there's
just
some of
showing
their
that
own
into
kind
the
of
rack
stuff.
level. So at the
That's
rack
right.
level,
Yeah, like I said,
what
if
we
you want
find
to
is
have
your
your
density is
own
super
language
important.
model,
Everyone's trying
and
to
you want to
optimize
run it
their
on
data
your
center.
on
Everyone's
the
trying to
silicon
optimize their power
that
output.
of your choice,
And
then
with
you
Venice,
can
every
make
major
that
server
option
OEM is
a
offering a
configurable
broad
parameter. You
spectrum
could
of
choose to
racks
do
for
that.
agentic
You may
AI.
not want to, but
So
you
what
could
that
choose
means
to.
is we
Yeah.
have the
If
full
enough people
spectrum
want it, you
from,
can do that.
25,000
Right.
cores to 50,000 cores, and that's
But
more
right now,
agents
like
per rack.
even
And that
if
gives
there's a
customers the choice.
say I don't
The
know,
key is every data center
Salesforce
is
or
different.
ServiceNow, right?
And,
Any enterprise
with that,
software, if
the
they
flexibility
partner
allows you to
with
pick
like
the
OpenAI,
right
right?
cooling, the right space
The
requirements
OpenAI,
for what you're trying to do. in your
OpenAI
data
don't
center.
actually allow
So there you
those
have it.
buyers
That's the best server
to
CPU
control
in the industry.
what silicon they're gonna be running.
Now, one of the ones that I guess we haven't really talked about is Oracle, and we all know they kind of go from bare metal all the way up to the application level. So
Yeah. So they can do that, right?
They could do it.
They
They're in
could
a
do
bit
it,
of
but,
yeah.
But they could do it, but are they actually making those available for a configurable parameter? Right? They're probably not because it's just too far.
Yeah.
It's too far below.
Begin
Right?
rolling out in the fourth quarter as we start.
But in a whole other kind of conversation, they are really borrowing against building out their investment and their AI investment. So who knows what all they're trying to do.
Privileged to partner with them as they've deployed multiple generations of both EPYC and Instinct. To share more about our work together, please welcome to the stage Meta's head of infrastructure, Santosh Janardhan.
It should be kind of interesting.
And they're building around AMD too, so yeah.
Yeah. Aren't they all really kind of hedging their bets?
That's bingo.
Yeah.
True friend.
Exactly.
I have to say, it's been a tremendous opportunity over the last few years. My story about Santosh is the first time I sat in his office, he said to me, Lisa, we're going to deploy a lot of CPUs. Please make sure they work. And I said, I will.
And you lived it up.
I try, but look, Santosh, Meta operates, you operate some of the most advanced infrastructure in the world.
I actually like how she's been presenting.
In the data center world.
Very, but she's like you said, Michael. She's so smart. I mean, she's brilliant.
Sure. First of all,
She's just very kind of, she knows the detail really well. I mean, she's just not like a, I don't know, a CEO who's kind of removed from the design and manufacture of the chip. Right? She actually knows it.
Either not been to a data center.
And so casually she could talk about this stuff like.
So this is
pretty impressive.
She just knows it. Yeah.
The thing I'll say about listen, we are seeing sort of demand go through the roof. When you look at inference, training, recommendation system, that's how a newsfeed works. Content creation, the demand for that is just exponential right now, right? And when I think about sort of the overall, Mark has this vision of delivering personal super intelligence to billions of people. So if you go to sort of Facebook or Instagram or WhatsApp or whatever surface you go to, the idea is that we'll meet you there and will deliver super personalized intelligence right wherever you are. And that's why we established this Meta Compute initiative. And because it's a top level thing, Mark himself oversees. Now, what it means is that we are now moving away from an area where we used to take servers, optimize it, try. This is what the conversations we were having many years ago that, hey, I'm deploying a CPU, I really need to maximize performance out of it. It's different now. You talked about how we should be thinking about the whole system end to end.
Yes.
We are at a point where we have to look about the whole data center and think about it as one integrated system. Servers, hardware, networking, cooling, power, all of that is not optional. All of that has to work together, right? And this is where I think there's a huge opportunity for collaboration with partners like AMD, because you have to now co-design, co-create systems, not just deploy sort of something that comes off the shelf, right? The other thing is, by the way, flexibility. The thing I really liked about what you said is that this is such a big opportunity in the industry right now. All of us need to lean in and sort of work on this together. So it needs to be open. It needs to be heterogeneous. And I think there's no one company, one partner that works for any one of us. We need to sort of work on this together. And that's why I think you're one of our most important strategic partners.
Thank you, Santosh. And look, we completely agree with your philosophy. Now, you are actually one of our broadest partners, because if you think about our work on CPUs, GPUs, we developed the rack scale OCP systems together. You deployed lots and lots of CPUs, so millions of CPUs, and you're a lead partner on Venice. Can you just talk a little bit about sort of your CPU infrastructure and some of our work together?
Sure. It's been many years. And the story that Lisa was saying was many years ago. I think we went from Milan to Bergamo to Turin, now to Venice. So it's at least the fourth generation. So long time partnership, obviously. I actually think the world is changing in the sense that the world is every year is a new world these days.
It's like every month.
Exactly. So what ends up happening now is that it's not just a GPU game anymore. It's CPUs and GPUs. If anything, I think CPUs are becoming at least as important, if not more. You're looking at a world where
you agree with that, Michael?
The workforce, the workload is changing because you have your workhorses and GPUs.
And
at the end
point about hedging bets,
there's agentic
sourcing is
systems, and all the code that's being generated still needs to run somewhere, right? So I'm super excited to work on Venice. I think there's a lot to come there. And you have to think again, this is a theme that I'm assuming will go throughout the presentation, that you have to start thinking about CPUs and GPUs as conjoined things. You hand off workloads depending on the workload.
Well, I mean, Apple's been doing that at a very small scale with a lot of their Mac Studios stuff.
Team. I think that's what I really appreciate about the partnership with Meta. Now, clearly, you're deploying lots of GPUs too, a lot of accelerators, and you're also one of our deepest partners on the accelerator side, starting with MI300, and then we had a very large strategic partnership announced around up to 6 gigawatts, starting with MI450. And what we're doing is quite unique with Meta.
Damn,
So
I mean,
talk a little bit
I don't know what the hell she just said.
Sort of the evolution
There's a lot of numbers in there.
plans.
Aspects of
gigawatts and stuff.
It's just really something now.
Capacity. I remember talking to you about that, right? And then
like I say, if you're not going to actually build
it's
your
important to
hardware,
sort of deploy that at production scale.
yeah, it really doesn't matter.
hands-on
You buy a
experience on both
laptop, you
sides.
buy a rack
350
or
is
something
the
like
first
that.
time we deployed this on a ranking.
It's like you buy a car,
systems.
right?
So that's
Do you
now
care what
getting
the
into
kind
some
of
sort
nuts and
good
bolts that they
numbers.
use to
And 450 is
connect the
I think,
door,
super
or
exciting.
what kind of
We just
glass that they go into the
and we are
window
going to
pane?
deploy it
I
across
mean,
the board
all
because
that is
it
just
gives us the
specs,
opportunity
those
to go and sort of
details.
really collaborate. I think the big difference between
There is some lunatic out there that actually does care about that when they're buying a car. What lug nuts are being used.
Power cooling.
Well, I think
Like I was saying, it's not just
to the extent that
and,
the car
we are not shy.
manufacturer or
They're not shy.
the dealers, right, let you
And
choose,
but
right?
you're very deceptive.
I mean,
Yeah.
some of them,
This is
they won't let you
what-
choose. I mean,
This
what
is
kind
the
of
point
nuts and
about
bolts is
designing
none of your
and
concern,
co-creating
right? So the
that.
factory would decide what
and
nuts
like I
and
said,
bolts they're going to
there's a
use to
huge,
optimize their
deployment coming
costs
in.
and their efficiency.
The more we deploy,
It's none of your concern.
the
You don't get
earlier
to
we
choose that,
co-design,
right?
the better
But
we are.
some
Yeah,
of them they will let you
absolutely.
choose. Like, for
Really
example,
appreciate
leather
you together
seats or what
on
kind of
MI450. Now,
something.
I'm going to ask you also about your crystal ball.
See, those are the
Look
people
out in
that
the
will
future
not
and
buy
you
an
see,
Apple
what the
device
next,
because
10
Apple
years
won't let
really
you do
means
any of
as
that.
you
But there are
push
people who
forward
love to
in
build
the,
their own
the AI
PCs,
industry.
and they will
One of the biggest
worry
challenges,
about the lug nut.
opportunities for
It's
us,
kinda
and this is
interesting.
the industry ecosystem here. So what should we be focused on as an industry?
Yeah, I think there are definitely people
all of
out
you know
there. Like
about the
I know
bottlenecks,
Paul
you know about
likes
the
to build the
power, the
PC,
data
his
centers,
PC,
the silicon,
and
like all of these, I
and
think, are choke points.
there's something that matters a
But
lot.
it's a
Some of them
pretty
that
will sort of
matter
work our way
less.
through. At the
Yep.
end
For
of the day,
example,
I think
like
the demand is
you may
immense.
choose. I mean, I don't know,
But the
motherboard
thing that
or
I really want
mother.
to
I mean,
make sure
or
persons realize is
versus
that
memory
we
versus
should
the
not
chip,
think
right?
about
Versus the
systems in
power supply,
isolation.
right? Power supply
Like I was
probably.
saying, CPUs
It's a
and
big one.
GPUs are one conjoined
Yeah,
system. We should start thinking about it
probably
that way.
commoditized. I
You
would
should,
say.
we
Yeah.
Probably if you buy a top-rated power supply versus a much
See,
lower
data
cost
centers
one,
takes years to build.
it's probably not going to be a huge
Like,
difference.
one of my
in
favorite
performance.
stories is Mark comes to me and says,
So-
"Hey, I want
That
to
even drives like what
You should have talked to me 2 years ago."
cage you put it,
It
the
takes
thing
time,
in.
right?
I'm
It's the
not
same
not
with
cage,
silicon.
but you know
It just
the
takes
outside
time.
shell of the
Yeah.
computer.
So we need to be starting.
Yeah, the
Anyway, I didn't mean to go into
RAM,
tech
yeah.
talk.
Design today. What we need to deploy in
Well, when you
2027.
talk about AMD, you sort
Yeah,
of
you can. Yeah, I remember 20 years ago I built a PC and I bought an AMD. I didn't go Intel. I went with AMD.
If you sit in a room and just go design
It's amazing
and in 20
to
years,
see
we'll be having much better
them
results.
and Nvidia where they are now
Fantastic.
compared to
Sandra, I
25
completely
years
agree
ago
with
when
you.
it was all
I
about
wanna say
gaming
again,
PCs.
Thank you.
Mhm.
We are so happy with the amazing partnership that we have, across the board, and most importantly, with your engineering teams. And we truly are excited about what we're going to do in the future. Thank you so
Thanks
much.
a ton. Cheers.
Thank you.
All right, we're about at the hour mark. I hope they're wrapping up soon.
Yeah.
Santosh talk about just the diversity of workloads,
But it hasn't
and,
felt like
the massive
boring.
scale
It's actually been really
of
interesting.
AI.
Mhm.
Now I want to turn to another part of the inference
Yeah,
market,
she's
where the
a pretty
requirements are
engaging
actually very
speaker.
different. So lots and lots of workloads, and as
Inference
inference is moving
market
into more products and
Segment.
services,
Workloads.
we're actually seeing it segment into different workloads depending on what you're trying to do. Some of these are, let's call it less interactive. So they're really tuned for, let's call it maximum throughput or the lowest cost. Other of these applications require more balanced throughput. So you have to balance throughput and responsiveness. And then there's this new class of applications that actually want very, very fast results. You have extremely smart engineers and they don't like to wait. And that is where ultra low latency or every millisecond actually matters.
Wow.
Each one of these types of workloads requires a different type of compute. And one of the best ways to reach ultra low latency today is disaggregated inference. So if you think about the different pieces, both prefill and decode are two different
Yeah,
jobs.
fast time.
So prefill tends to need more compute, decode tends to need more memory bandwidth. And with Instinct, we have a very balanced machine so that we deliver both great compute and great memory bandwidth. But you can actually take this a step further. If you know what workloads you're trying to run, you can actually let customers tune each of these pieces independently. And to address this market opportunity, we've been working with Cerebras. So to talk more about what we're building together, please welcome to the stage Cerebras co-founder and CEO, Andrew Feldman.
I am completely unfamiliar with Cerebras.
They
Andrew, it's great to have you here. It's been exciting few
they have
months.
data centers
You,
that
know
runs on
that,
these massive
for those who
chips.
don't know exactly
Like this
what you've been working on. Can you talk a
big-
little bit about Cerebras and
You know,
what
they,
problems
instead of
you're trying to solve?
putting many chips together,
Sure.
they just manufacture
Great to be
a
here.
gigantic one.
Great to be sort of among people who love hardware.
Yeah,
Yes.
you're in the right place, buddy.
Look, I'm thrilled to be here with you and to announce our cool new partnership. At Cerebras, we build the world's largest and fastest chip. It's a full wafer. And we package
The
this
whole
into a system. And
wafer is one chip.
right, into racks and then racks into clusters. And we deliver them both on premise and via the cloud. And you've had some of our customers up here already today. On the Frontier Labs, we serve customers like OpenAI. And in the hyperscalers like AWS, in the small agentic and the coding space, leaders like Cognition. And they do this because we're blisteringly fast.
There's no question, Andrew, that you have some tremendous innovation with what you've been working on. And our teams have been collaborating really closely over the last few years to really have Helios together with the wafer scale engine for ultra low latency inference. Can you just educate the audience a little bit? What are we trying to do, and what does that mean for customers?
Sure. I think what's happened, and you described it previously, is that sort of AI has moved from being a novelty to being useful, and then in some domains a necessity. And when something's a necessity, people want to use it, and they want to use it quickly. And to serve this market, this segment of ultra low latency, we sought a partnership that could extend our capabilities and our footprint. And there was no better answer than AMD. We were already an AMD customer, as we use AMD CPUs to surround our systems. And we were so excited at the opportunity to build a disaggregated solution that combined AMD CPUs, the cool new Helios rack, and the Cerebrus wafer scale engine.
Yeah, look, the technology is pretty cool. So just talk a little bit about how it comes together.
Sure. So as Lisa described, what you have with Instinct and the Helios rack is you have the leader in performance and memory capacity. And you marry that with our wafer scale engine, which is the leader in SRAM and in memory bandwidth. And that combination allows us to deliver a solution that is unmatched in the industry.
So very, very exciting. I know that customers are excited about what we're going to do together as well. So when are we going to have it in market?
You know, like when you build
later this year, it will be
entire chip on an entire
the
wafer.
Cerebrus cloud,
then the
and
communication
it will be later
bandwidth
at a
much higher.
store near you.
Because you don't need to. Normally, a chip is like the size of a fingernail.
Customers some choice to really put together
hundreds and thousands of these chips.
And I think we're very, very happy to be able to do this together with you. I think it's a huge
step.
step.
Build an entire chip like a gigantic one, like the size of a wafer. That's like
I think that's right. I think until recently, customers sort of
you eliminate that communication
sort of high throughput, or they could have extraordinary.
And you just made me hungry.
By
Thanks there.
Together, the Helios rack with the Cerebrus wafer scale engine, we give you 5 times the throughput while continuing to deliver this extraordinary speed. It's really something amazing.
Fantastic. Well, look, Andrew, huge congratulations to what you and the Cerebrus team have done. I mean, I think it's been incredible. I think you've been clear on what you were trying to accomplish. And it's really nice to see not only it come together, but us come together to offer a solution that will be very, very compelling to customers. So we can't wait to get this into customers' hands.
Soon. Good to see you. Thank you so much.
Thank you.
He sounded like he really meant that.
All right, so look, I think we've shown you a lot of hardware this morning, but as we all know, hardware is only part of the story.
Oh my God.
It's actually software that turns all of this into a platform that developers build on. So to share the progress we're making with ROCm, please welcome AMD Senior Vice President of AI, Vamsi Bopanna, to the stage.
Thank you, Lisa. Good morning, everyone.
This is supposed to run until 2.
It's great to be back to talk about software.
All right, we got 23 minutes.
Programming AMD GPUs required deep expertise and significant engineering effort. We've come a long, long way in a remarkably short period of time. Through our open source community collaboration and sustained investment in ROCm, our software stack, AMD Instinct GPUs are powering some of the most important and consequential workloads on the planet. But the biggest change is still ahead of us. AI is transforming how software is getting built. And we are bringing that transformation to ROCm. And that's what I'm excited to share with you guys today. Our software teams have been moving fast with relentless focus on developers. We've invested at every level of the stack in build and test infrastructure so we ship faster. ROCm releases now go out every 6 weeks, not every 4 months. We've continued to expand the work we do with our AI ecosystem partners. And the result? More features, faster performance, and and a significantly better out-of-the-box experience. Our strategy that has gotten us here has been remarkably consistent. It's built on two core principles. Partner deeply with the open source ecosystem and build with the right layers of abstraction to enable developer productivity. Open source gives us velocity and scale, and abstraction makes developers more productive. A deep commitment to open source has resonated with the community that has truly embraced AMD. From frameworks and compiler stacks to inference engines and model hubs, AMD is now becoming part of default enablement for the most important AI communities, such as Hugging Face, PyTorch, JAX, VLLM, and SGLang. This is why new models get day zero support and why the world's most important AI workloads run on AMD today. That is a big shift. Inspired by engineers seeking productivity, abstractions have evolved to enable work at the right level of detail, hiding complexity when they want speed, and exposing control when they need performance. From low-level programming in assembly and C to block programming abstractions like Triton to Pythonic frameworks, we've invested in key abstractions. Ater, our kernel library, and Atom, our serving engine, get you peak performance without writing the kernels yourself. Fly itself is a brand new Pythonic domain-specific language that gives you low-level levels of abstraction, the performance of hand-tuned C++.
At the chip
And
level,
Maury,
it's
our
just
communications library helps deliver leadership performance on the latest models, like
several
Minimax.
layers of abstractions. Like.
But look, something very, very exciting is happening. Over the past year, I've seen something remarkable inside AMD. Our engineers are using AI models to generate GPU kernels, optimize code, debug issues, and improve performance. And in some cases, these AI-generated kernels are shockingly good, better than what we expected, sometimes better than the most manually tuned versions. The first time you see this, you're a little bit skeptical. You run more tests, you try to break it, you look for what went wrong, and then you realize this is real. What has happened in general software development is coming to significantly transform GPU programming. It's going to reduce the time it takes to bring up workloads, make optimization automated, and it will remove any remaining barriers to broad adoption. We want to put that capability in the hands of every developer. So today, I'm excited to introduce Rock'em.ai.
He's very excited.
Yes.
It's an agentic AI platform that brings the capabilities of AI-assisted GPU programming to developers. It starts with the simple idea of giving developers access to the power of an AMD ecosystem through the AI coding agents they already use. Whether you're using Cursor, Claude, Codex, Rock'em.ai helps those agents understand AMD platforms, understand Rock'em, and helps you build and optimize your workloads. In other words, we are making those popular coding agents into super users.
That's for
Even
the performance,
even the engineers at Salesforce or ServiceNow probably won't. Like I said, the only case they would
building the open software foundation. Now we are adding an AI-assisted layer
their own LLM,
that helps
right?
developers use that foundation faster and more
very likely they would just.
So let me show you what is inside Rock'em.ai.
They would just use
It's built on the foundational capabilities of Rock'em, our core software stack: runtime, libraries, compilers, tools, framework integration. All of the core software that makes this work.
It's like right now,
on
if
top
I
of
ask
that,
you,
we built a layer of
what
AI
code, what kind of language
called
is
Hyperloom.
Salesforce written in?
Using Hyperloom, the system can analyze workload, tune configuration.
We don't even care at that level. So forget about the software that controls the chip.
And iterate towards performance goals. To give you an example of the
they're not going to be doing any GPU development.
I was talking to the lead developer last week. He told me they just pushed through a suite of 14,000 models through Hyperloom, optimizing them and creating valuable insights. This would have been impossible to imagine, even with a large team of engineers before. That's the power of Hyperloom. And finally, we provide an AI native interface for our
Funny when you look at AI agents,
ROCm natively.
it's a completely different
I'm
context than what he just
incredibly
talked
excited by what we
about.
have built with ROCm.ai.
Like he's
it's going to profoundly
at a, like you said, at a much lower level of development.
Yeah.
So let me make this.
Yeah, it's a level of
with an
abstraction.
example.
I mean, kind of there. It does
Imagine
matter.
you're a
It does trickle
developer
down to
who
you.
wants to optimize
But
Minimax
it's
M3
like,
with VLLM on
I'm trying to understand like how a human
Today,
body works, right?
There are many things you
I
need to
know
get right.
every single
You need
atom
the right
inside me
VLLM
matters.
optimizations, the right
but
model recipes,
I can't control
the right
it.
environment
So it
variables.
effectively doesn't matter.
We need to write
Right?
new kernels.
Every single
optimize
molecules
kernels.
in my
And
body
then you still
matters.
need to tune all of
But
this.
I can't
With
control every
ROCm.ai,
molecule in my body.
This interaction becomes
not
much
literally, I can't even control every
So let's
cell
see.
in my
You
body.
can say,
so forget about the atoms
optimize
or the molecules.
Minimax
Right?
M3 with Hyperloom. Enter. And behind the scenes, the agent does what an expert would do. Pulls a known good recipe, runs and profiles the workload, it creates and tests a bunch of kernel and runtime configurations, and it keeps iterating towards target. You can actually watch on screen here, ROCm.ai write a GPU kernel. It sees an opportunity to write a more optimized MOE group gem. And the result, ROCm.ai delivers a 38% more tokens per second improvement on this specific example. This is the experience we want for developers. Simple to start. That's pretty cool, huh?
That is pretty significant.
Simple to start.
Probably not.
Optimize.
We're not gonna use it, but
focus on performance. With every release, we
pretty
deliver significant performance gains. On leading models like DeepSeek, ROCm.ai delivers 3.3
He said once they're
times
developing their own models.
7.
Yeah.
This has been made possible by innovations at every level of the stack. Techniques such as the use of block-scaled fused MOE kernels, KV cache quantization, expert parallelism. But look, the bigger story is how AI agents actually profiled the workload, proposed new kernels, tested configurations, and actually validated all of the results. That exact same focus is also on delivering performance gains for training. On the same hardware, ROCm.ai improves training performance by an average of 2.4 times. Through optimized kernels such as fused flash attention, more efficient checkpointing, and advanced parallelism strategies. Our engineers have done amazing work to unlock the capabilities of MI455 through ROCm.ai. So I'm delighted to share some incredible results on hardware. On running real workloads, we are able to see the system deliver 20 terabytes of memory bandwidth, 20 petaflops of delivered compute. These are the highest demonstrated compute plus memory capabilities of any accelerator platform in the industry today. It's not theoretical, there's measure. Super exciting that we were able to share this on day one. I'm also thrilled to share that the leading AI ecosystem partners who have had their hands on MI455 have had a delightful experience. You can see here what they've had to say. From end-to-end PyTorch testing to ensuring Hugging Face models are getting validated to VLLM and SGLang running well on MI455, we are incredibly encouraged and excited by what the community is about to unlock with MI455. This matters because Daisy.
Michael, is this something that is making an impact on you?
Enables. So now let's look at ROCm.ai.
Not really. I think, like I said, I don't have a choice, right? I mean, I use these.
Let's deploy DeepSeek.
I think maybe 20 years ago when I was in grad school.
On Helios.
More than 20 years ago.
Now watch what happens.
When I had to do some hardware optimization.
It configures the runtime.
That's when it matters a little bit for me. Yeah, but today,
and finally, serves up the model.
Yeah. So are they like trying to wipe away, I guess, NVIDIA's advantage for the past 50 years or so?
Right, a simple point now.
Software can
advancing AI.
Do it.
Let's hit enter.
Sorry, I didn't quite get that question.
So,
like two-person talking, I have a hard time.
50 years in writing kernels and test configurations, right? If now you can do the
This is
same
the
thing,
experience we want to give our users.
software written by
The
agents.
developer should not have to manually.
Sorry,
listen to
I find it very hard to
model
hear you and
architecture,
him talking over each
selection
other.
from
Let me see
strategy
if I could
and
mute him for a second.
AI is transforming.
Maybe just lower the volume a little bit.
Yeah, hold
Because
on.
I
Let
think
me,
your voice and his voice
and
Oh,
software.
okay.
kind of
Same
it's
frequency.
it's probably
How about-
similar frequency. So it's
How-
hard to hear.
how about now?
OpenAI.
Maybe-
Lisa and Sachin.
Go
Try
ahead. Sorry.
Can you hear me now?
Dave, give him the
Yeah.
question again, Dave.
Yeah, I was saying that are they trying to wipe away, I guess, NVIDIA's advantage over the past 15 years? Writing the kernels, testing configurations, workload, where now you can have like the agent, or the software written by the agent.
Yeah, I think part of it, I think NVIDIA's really strong moat is their CUDA kind of language, right?
Yeah.
I think they're appending that with the open source ecosystem,
Yeah.
right? They're trying to do the open source. But I think, NVIDIA can optimize the kernel too, right? For dependent workload. I think you'd be stupid not to do that. Because, optimization of kernel for specific tasks is just something that people in hardware normally would do anyway, right?
Yeah.
For sure. Well,
Yeah.
first of all, thanks so much for having me. I was here
Going back to OpenAI.
Be back now. Look, our
Let
way
me
of looking at things
bring the
is
sound
there's
back up a little bit.
one way to fit all applications, and we really
Yeah, sorry, Dave. I think your voice,
So-
your tone
Yeah.
is very similar.
Frequencies are meshing.
Like Brent's voice is a lot deeper, so I could hear it like a different frequency.
we've developed written, as you
Just call me the Barry White of English.
Baritone.
We've been in a case where we've had to hyper optimize.
So I guess my point is
give us the level of
AI is being used to solve the software problem, right? That determines whether chips can compete. So
and this show we've been really able to
I think that
kernels
yeah,
for
that is the case. There will be more and more the case. AI will be used,
like agents
to
make sure
optimize the software, and that optimizes that's used on their own computation. So it's a little bit of that
we're seeing
feedback loop. Yeah.
agents sort of taking over, they're getting just very good, as you just mentioned, at writing this kind of code.
Amazing. So look, I think the work you have done with Triton and now Gluon, right? It's been really, really moving the ball forward for the entire industry. Now we began our work.
This is the only
100 and,
conversation that
350,
Lisa
but now
hasn't
we're collaborating at a different
posted,
scale
isn't it?
with 450 and
Yes.
Helios. So would love to hear your thoughts on how that
Need a
collaboration
break.
is going and how that experience.
Well, I'm hoping the break is at 9 minutes from now.
Yeah.
I think we started years ago on hardware.
Maybe another 2 hour.
No, no, I will be on break at that point.
It's so nice to see the outcome of that.
You just ate up your lunchtime, Brent and Rebecca.
Yeah, Michael. Somebody started mentioning pizza. I'm like, all right, we got to stop that.
Yeah, that's Cerebra. Their chip is literally the size of the whole wafer. So it's literally the size of a small pizza. Yeah. So
so that
sounds good to me right now.
and the whole thing is one chip. That's the thing, right? So normally when you make chips on a wafer, right? Each one of those wafer the size of a pizza, right? You cut them into little chips that's the size of a fingernail, right? So that's about the typical size of a chip, right?
Yeah.
Even smaller, but that Cerebra's their differentiation is that they make the entire wafer. It's just one gigantic chip.
To confirm that.
Yeah. So there's no more communication overhead. So it's really, really fast.
And we can get in a very, very good place.
Awesome. That's awesome to hear. So look, one of the more amazing things that we've done recently, right, is teams have collaborated even more closely in terms of, using AI to program AMD GPUs. So, would love to hear your thoughts and anything you can share with the audience.
Yeah, no, I mean, everyone in this room knows how much agents are taking over our jobs in a sense as kernel engineers. And it's been amazing just to see how much better they've got over just the past 6 months. And just now they're extremely good at generating just high quality GPU kernels in a way that we're not before. And it's been very great collaborating with AMD on just making sure that agents not only are capable enough, but also have all the right context they need to be able to make good decisions and good optimizations.
That's great to hear. Yeah, I think the quality of code that's getting produced by AI-assisted kernel generation has been truly remarkable through our collaboration. Very excited. Now, as you look ahead, right? What crystal ball do you have for us for the future of AI software ecosystem and collaborations like ours?
Yeah, so there's two things that really come to mind. One, as we keep talking, is just how good agents are getting. And the other one is, I think, how much the open approach to software of AMD is enabling, not only for OpenAI, but I think for the industry as a whole. I talked a little bit earlier how we've been collaborating on LLVM cogeneration. LLVM is an open source project, but the entire compiler stack from AMD is open source. And that has allowed us to make our agents really good at very, very low level cogeneration, down to scheduling instructions in assembly. And this has led to very, very significant performance gain that I don't think we'd have been able to achieve in a fully closed source stack.
Yeah, that's one of the real sort of big value propositions that we have to offer, right? Because everything that we do is in the open. And
Michael, he just said it. Agents are taking over.
Is a big one. Thank you, Philippe. We truly appreciate the partnership, and we're really excited about what we're going to build together.
I mean, not just yet, but I think very soon they will. Even what you say, kernel engineering and definitely software engineering is, if you're on the UI UX layer,
and the closed hardware software design, we can create incredibly
heavily disrupted.
And that's exactly aligned with our strategy. Now, everything I've shown you so far has been about AI, but ROCm is also a great stack for developing high performance and scientific computing applications. From frontier models to climate simulation, we use the same ROCm, the same library, same tools, same AI-assisted development, one open stack for every single workload. And in fact, when you look at our roadmap, we've retained that very strong focus on HPC and scientific computing. Just like MI435 leads in AI compute with every performance, MI430X leads HPC compute.
That CUDA ecosystem and developer base is pretty hard to disrupt, though, isn't it?
For two very different
it is. Yeah, because there's so much lead time, right? I think there is something about being open, right? If you have this completely open source, right? Then you get a lot more people work on it.
Yeah.
So potentially, you have the entire world, right? To anyone who knows anything about software engineering, they can work on it to improve this. So they actually catch up very fast. Right? It's the same thing. How this China AI is able to catch up so quickly. It's because they leverage the open source their code. Right? So everything that people develop goes back into
MI430X ships in the first half of 2020
to the open source. So
is why.
Wasn't there something that came out where one of those model companies in China put out something that they later found out was they actually kind of borrowed from Kimi 3? Yeah, didn't they borrow it from someone?
Yeah. And it's a little rich because all the models borrowed and stole stuff. So it's a rich accusation, at least.
Yeah, it's a method called distillation, right? So you basically train a smaller model that's more efficient from a bigger model, and so basically think of it as you want to train a student to learn from a teacher and learn as much as you can, right? So the student basically asks the teacher thousands and thousands of questions to see how the teacher responds, so you learn that. Right? So and you could do that for any model that you want, right? To train, right? So the question is, who will be the teacher? Who's the teacher, right? So they have to learn from some teacher. So a lot of people are speculating the teacher is probably either GPT or Claude or something. Right? That's why they are kind of measures that they actually put in there to prevent company from distillation attacks.
Please welcome to stage Senior Vice President and General Manager of Compute and Enterprise AI, Dan McNamara.
I hope Dan is hitting cleanup here.
Thank you,
I'm not so sure, Brent. I mean, these hardware conferences, they could go on like 3-4 hours.
No, we're not doing that there. Not today.
Everywhere. And the vision behind this has remained the same for
Enterprise
several
AI,
years
okay.
for us. To deliver the right compute engine to the right workload, and then continuously drive optimization points across our entire portfolio, from CPUs, GPUs, networking, and FPGAs. So building on what we've already shared,
FPGA,
field programming gate array.
Okay.
And how
so it's basically a chip that's programmable.
Franchise
Okay.
has truly positioned.
Yeah. So when you manufacture a chip, normally the circuits are kind of fixed.
So
when you have an FPGA, you can actually change those circuits by software. Yeah.
Really does help having somebody who knows what the hell they're talking about on this thing with us.
Yeah, FPGA, they're not as fast as the actual chip, but if you want the reprogrammability, then it's a huge advantage. It's still much faster than software.
And each of these,
so like software is completely customizable. You could you can write
are usually constrained,
program the software to do anything you want, right?
Usually must operate,
but it's
fairly limited compute and memory.
It's slower, right? But if you want it to kind of
in
high speed, right, then you actually turn it into a chip.
And
a chip
AMD
you cannot
is
change
the only company delivering a complete
the circuits are fixed right inside chip.
Development.
So if you want something in between,
so I just mentioned
you want it to be programmable, but you want it also to be faster than software.
I want to touch on it a bit.
Then
With each generation of EPYC,
So he's talking about personal AI and
address their evolving needs.
enterprise AI. Okay.
Highest performance, lowest total cost of ownership, and the fastest time to value. As Lisa mentioned earlier, we've introduced many industry firsts across our generations that our enterprise customers has actually asked for. And that customer focus has brought us to where we are today, with EPYC as the leader in enterprise computing. And over the last 3 years, there's been very, very strong adoption across the enterprise, with the world's largest companies moving more and more workloads to AMD. And it's reflected in a number of places. First, public cloud, where our VM consumption has grown at 76% CAGR over the last 3 years. And on-prem deployments with our OEM and ODM partners is growing quite aggressively across key industries. But just as important, this position allows us to understand truly the diversity of the workloads that our enterprise customers run every day. And each workload places new demands on the CPU. Some require maximum thread count, some depend on per core performance, while others depend on memory bandwidth, cache efficiency, or I/O performance. The really important point is that there is no single SKU that solves every enterprise application.
Of course not.
And that's why our EPYC portfolio with Venice spans 8 to 256 cores with a range of power, frequencies, and I/O capabilities, giving customers the flexibility to choose the right solution for their workload, and most importantly, at the most optimized cost. So Lisa mentioned this earlier, and now we all know we covered Venice, and she showed how we have strong leadership across AI host nodes and the agentic workflows. But I wanted to show you how Venice actually leads across the general purpose workloads of the enterprise, and these workloads that are running, our customers rely on every day. As you can see,
so the key here is that
2.5x performance.
Right? Most
for competition
enterprise workloads are very different from each other. That's why you need that generality.
Now, as we all know, agentic AI
that's why it's more CPU bound
transition
rather than
the enterprise.
GPU bound or
And
CPU.
it truly is a force multiplier for enterprises, and adoption is accelerating. In fact, the latest data here shows that nearly every enterprise next year will have some form
So
of
is
agentic
CPU then more so focused on orchestration?
And as enterprises move from pilots to production to
Yeah, you could say that because
we've talked to CIOs.
when you do orchestration, why do you need orchestration?
Yeah, three major
The reason you need orchestration is because
predictable infrastructure
tasks that you do are very different. They need to
Secondly,
be kind of,
making sure the data is
orchestrate them so they don't step on
and
each
then
other's toes.
lastly,
Right?
and
So-
sometimes this
And
is
that's why, because each individual task
to their
is so
existing
different.
infrastructure.
Right? You can,
It's
you-
not
you
all
know,
greenfield out there for
yeah.
the
So like, imagine you have a.
So
Just imagine
to
5
solve
things
these
you need to do.
problems,
Right?
we
If I
truly
want to
believe
reply
this
to email,
might be a
generate
distributed
images,
deployment
analyze
model
data,
that leverages frontier
or something.
models.
These 5 things they could
services,
happen in
on-prem
any order
infrastructure,
you
of course,
want.
AI
Right?
clients.
So with that, you need orchestration.
As
right? So
AI
like,
has moved
what
from
if one thing did not finish and I need that
prompts
CPU to do like
agents
generate
doing
image,
work, writing
that
code,
which takes a lot more compute
summarizing
than
documents,
but I
and
want
running
but I need it
complex
for my
plans.
data analysis, which is more
The
urgent. Right?
requirements
The
have
image can
evolved
come out
also.
later, it doesn't matter, but I
And
need
those are
so you need
exactly
to orchestrate it so that
we've
it
been designing for.
meets
for
your
multiple
demand. Right?
So
But
well,
different
AI
people
will
have
be
different
deployed
demand, right?
across all
For
these
different
environments.
job they
The
want to do.
on-prem
Right?
deployments
So
and
a marketer,
have
they want something
fairly
different
unique
from
constraints.
someone who just want to respond to
Performance,
email
power,
or something like
cooling.
that. So yeah, that's
Big
why
challenge in
a lot of
space.
the enterprise
And of course,
like agentic
costs
workload
remain top
are
is for
CPU
CIOs
bound.
that are trying to
They need more orchestration because they're very different.
Lastly,
What you need to get done versus what I need to get done is very different. Right?
Yeah.
Even if 2 person in the same company with exactly the same role, right?
But it has to.
Two like
That's
I
something we're
don't
very,
know,
very focused
two
on. So to address these
marketing
concerns,
kind of
thank you,
manager,
Mark.
social media manager,
I'm
exactly the same role
very
in 2
happy
different
to
companies. Right?
announce
May
the
have
launch
very different
of the Instinct
tasks that they need to
MI350P.
automate.
Yeah.
Yeah.
This is the local AI competitor to what NVIDIA is doing with that Spark thing.
AI in the data center.
I
But
think.
the challenge
No,
is
maybe
how
I'm.
do you add those capabilities
AI to the
without
data
starting
center.
over? That's exactly what the 350P was designed to solve. It's an air-cooled GPU designed to fit within the power and cooling of enterprise servers today without a facilities upgrade, making it easy to bring LLM scale inference
Wow,
into
that's
today's
pretty-
enterprise data center. And at the same
Pretty
time, there's
small
no
for what he's
compromise
talking about.
in capability.
Yeah.
A single MI350P can support up to 260 billion parameters.
Damn. Okay, that's.
The majority of enterprise AI workloads on a single GPU.
Well, you know, Apple is creating are said to be doing a Mac Studio that could have 1.5 terabytes of RAM right in that one thing,
Oh, yeah.
and the memory bandwidth is like something ridiculous.
Yeah.
So you could actually support a trillion parameter model at some point, right in your home.
Probably not trillion. I think you probably get to hundreds of billions.
Well, I think 800 billion was the one that he said it was.
Yeah, I think that's probably high hundreds of billions, but I don't think they'll be able to support a trillion.
What's the biggest model right now in terms of parameters?
Fable, like
Oh,
10
well,
trillion.
yeah.
2 to 5 times faster.
Fable 5 from Anthropic. But
Is that back to being public, or have they snatched it back?
it's public now.
Okay.
It's public.
Yeah.
I just used it this weekend to write code, of course.
Do you have like the premium $200 a month thing?
No. No, I don't. Not with Anthropic. I think they are kind of too expensive. I feel
Yeah.
like. So-
So you're able to access that. I'm sure it chews
Yeah.
right through your your budget. But
Yeah.
What is that, at the
That's
$20
famous product,
a month?
That was insane.
yeah,
Yeah, I only use it to do very specific thing that I think is very, very difficult. Like, planning the whole architecture or something big. And other than that, I use something else to actually code it up, to write the actual code.
Probably one of the faster growing agentic applications.
all right, buddy, you're running a little long here. I'm hoping that you somebody's gonna be wrapping it up pretty soon.
Brent, I don't think you know these hardware conferences.
No, I don't think
These
I've been
are-
to a hardware one.
They're much more hardcore. Just think about it. You probably heard a story that these hardware engineers at TSMC, they're on call 24/7.
43%.
Wow.
Delivering up to
Well, I know-
What does TSMC sell? They sell production capacity. Right?
So we believe this
if you have a 1 second of downtime, right? That's
1 second.
like, literally 1 second of downtime.
From our history
That's a lot of millions of dollar loss.
That is
literally
crazy.
because your production capacity is what you actually sell.
And over the last several years, we've truly
So
grown
you cannot have downtime. So you have to have engineer on call 24/7. If they call you like 3 a.m. in the middle of the night, you go there and fix it.
Support for all of the industry's leading open models. And
So they're
frameworks that help customers.
power
AI
people
into
have
production as fast as
extremely, I would say,
It's all built
ability
on
to
trusted platform software.
sit through these arduous,
and
long
enterprises
kind of
rely on every single day.
Well, Jensen's GTC keynote was 2 hours, and it was just him on stage. He wasn't bringing on anybody else. He was just rolling.
Yeah, he's marathon man.
Whether it's in the cloud, on premise, or in the
I know she's taking a break here.
So to bring this to life, I'd like to welcome Jeremy Legg, Chief Technology Officer at AT&T.
Jeremy might be the last one I'm gonna hear from. This is. We'll see.
Yeah, this is great. It's kind of a homecoming. I grew up in the East Bay, so it's good to be back.
Yeah, fantastic. We really.
Oh, they're at my Stony.
Today. So look,
I think.
Yeah. AT&T is
down the road a bit, up the road for me.
Company, one of the largest in the world, and I'm sure all these people, half of them out there probably have AT&T network right now. But
hopefully more than half.
Yeah.
But yeah.
So, AI is touching way more than the network, and you and your team are really doing a fair amount of work driving it. So can you share with us sort of the opportunities you're working on and your experience to date?
Sure, happy to.
Now, if you're sitting in the audience right now, and it's you're about an hour and 40 minutes in, are you getting antsy?
That number has gone up pretty dramatically. It's moving up double digits. So
Not if you're a hardware
it's
person.
very pervasive inside of the enterprise.
Like
Gen A models
I think
production across
I think
enterprise as well. And those are
for people who are
things that I think
would say like kind of
doing in customer
more lower
care.
level, right? You just need a lot more patience.
But
Because
also
those type of stuff, the nature of the work that you deal with
a cell tower or a RAM that is the most effective use
takes
of
longer
of a network.
do everything.
So all of these things are happening across our
So I
enterprise,
think
but they're happening at a scale
even
that is
at
not
a
necessarily normal.
data science,
We get
or
over
kind of machine learning
300,000
conference,
calls a day.
it could go pretty long.
Transcription of those calls
People
is
are
the
able to
numbers
hold their
workload and
attention.
driving the insights out
much
of those
longer.
calls that we then bring back.
Whereas
to
a lot of the
business,
business
another
conference, they
set
tend to
of
be
insights.
shorter.
So it's
because
a
maybe people
really
just don't
interesting
have
thing, and now we're
enough
beginning
patience or
to
enough
actually
kind of attention
rebuild
span
entire
to hold through.
workflows inside of the
Yeah,
company.
the older I get, the less patience I have.
Although, do you remember that when you were there, Brent, when Larry Ellison's Sunday night keynote?
Oh, that Sunday night, that was horrendous. Oh my God. The only thing that was worse than that, back like years ago, I went to a SaaS thing with Dr. Goodnight.
Oh, yeah.
And he was talking at Saturday evening.
From SaaS Institute?
That's brutal.
Yeah.
Yeah, but you see, I mean, yeah, Dr. Goodnight is a analytics guy, right?
Yeah.
I mean, he's a very technical, also kind of down pretty low level. He's not really a business person either. So he's able to kind of just plow through those detailed law and hold their attention, hold their focus. Right?
Well, he plowed through. I don't know about holding the attention, but
Well, he can. I think a lot of people who are working at that same wavelength, they can. Right?
Yeah.
I think if you're talking about the more business people,
I have to say,
much harder time. Right?
I gained more so for Larry Ellison. I gained a ton of respect. This dude is, at the time, he was in his mid to late 70s, and he was talking at the bit and byte level, and he was completely into it. And I'm like, and this dude owns his own island. I'd be like, there's no way in hell I would be here talking bits and bytes when I got an island and I've already got more money than I'll ever know what to do with.
Yeah.
But he was into it, which is like, wow, this is amazing.
But Larry is a trained engineer, right? So
Yeah.
he's also kind of
different sets of
has,
chipsets, building
he's,
our own models.
Yeah, he's a trained billionaire too now.
We're
So.
one of the few companies in the world that's actually post-trained a model on AMD and then been able to drive equivalency in terms of performance and accuracy with
All
other
right,
more
buddy, keep
expensive chipsets in the market.
Start wrapping this up.
So as we have done that, we've been able to drive down token costs essentially through moneyballing across all of these different models and leveraging.
Moneyballing is
moneyballing.
Made a big difference.
Oh, you mean like from the movie Moneyball?
Even though token consumption is going,
Wow.
Is that what he's saying?
I think that's what he's saying.
Yep.
Scale, which is not a small thing.
Yeah, it's just it's a bunch of great work. Another key area that's sort of groundbreaking, which is exciting also, is you're the first telecom company to actually train a model on AMD, and also you're driving fully open source models in telecom. So tell us about that experience and why you felt like that was needed.
We felt like the industry was moving down a path where folks were only going to use closed source models to solve solutions.
They're really hitting NVIDIA on this open versus closed stuff.
And that we didn't want to lose sight of the fact that open source models were going to be a very significant part of the solution. So we announced what we call OTEL 1.0. That's the Open Telco AI model. A bit over a year ago so now, and we had over 18 million
45 billion tokens per day
since then. We're excited to announce today the launch of OTEL 2.0, which is a more advanced set of models that we have trained on AMD, and we're now making that available via open source across the broader industry. And it, I think, is going to give folks an opportunity to see that not only do you need to think about leveraging models, but you also need to think about training those models and how they work across your enterprise.
So that's just great. We certainly appreciate the partnership, and we really feel like this is germane to the conversation. It's exactly.
So you see, if you're training your own model, then it matters. Right?
Thank you.
Yeah.
This hardware matters, but if you're not, then it's probably not in your control. Right. I mean, it does matter, but if you can't control it,
we've established ourselves as a leader in enterprise computing by listening to our customers and delivering the right solutions for their workloads. Today, we're extending that leadership to help customers accelerate their AI journey. This is our vision for powering AI everywhere. And to expand a little bit beyond the data center into physical and client AI, it's my pleasure to introduce Mr. Jack Yoon, who leads our computing and graphics group. Thank you.
Client AI, I haven't heard of that one before. I've heard of physical AI, of course.
So many friends, partners, and developers here in San Francisco. Today, we have seen how AMD is building the compute foundation for AI in a data center. But the full AI transformation requires two more ingredients: intelligence that becomes personal, intelligence that can understand and act in the physical world. Those are the two frontiers I want to explore with you here today. Let's begin with personal AI. Enterprise AI is already reshaping the data center, but agentic AI will extend far beyond it. Agents are the next great productivity multiplier. The jump from software that responds to software that completes work. A personal agent can double what one person can do. A team of agents can multiply that by 10. And as agents gain more capabilities, opportunity can grow exponentially. But that promise has a compute consequence. Unlike a single AI query, this agent reasons, calls tools, in coordinates to other agents, and run nonstop. Agents become more capable and pervasive. So will token consumption, meaning that demand will require every layer of the computing ecosystem to scale together. Data centers remain the foundation for frontier AI in the most demanding workloads, but edge and client systems can extend that capacity, putting more intelligence closer to where data is created and where the work gets done. The PC is already one of the most powerful compute engines ever placed in the hands of an individual. Across billions of devices, enormous computing capability is already deployed every single day, yet its potential remains largely untapped. Putting that capacity to work changed the economics of computing. More workloads can run on systems that are already in place. reducing overall infrastructure costs and allowing data centers to focus on the largest, most demanding task. And local computing brings inherent advantages. Your data stays with you, your applications remain responsive, and your system keeps working, even when your network does not. And thanks to a new generation of smaller, more capable AI models, we're beginning to unlock that potential. And the unlock is happening faster than anyone expected. Last August, GPT OSS needed 120 billion parameters to score 80 on GPQA. Just 7 months later, Qwen 3.5 scored even higher with only 9 billion. Better performance with 13 times fewer parameters. This is not an incremental improvement. It's a dramatic shift in the compute required to deliver advanced intelligence. And this is a trend, not an outlier. Smaller open models are closing the frontier gap at extraordinary speed. Qwen 3.6 27 billion parameter model now outperforms leading frontier models from the previous generation on graduate level reasoning at a fraction of the size and cost. That changes what is possible. Workloads once reserved for the cloud can now run on powerful compute engines designed for personal AI compute. Let's map these model performance breakthroughs to AMD platforms.
So when you get to like
AI
9 billion parameter, you could even do it on your phone.
Models up to 24 billion
You
parameters.
get edge compute.
More than enough for Qwen 3.5, 9 billion, with substantial headroom. Ryzen AI Max extends that capacity to models as large as 200 billion parameters, running natively on a personal system. This is not reduced AI, compressed to fit on a PC. It is a new class of personal computing built to run powerful models where the work actually happens. And this is exactly what led us to build Ryzen AI Halo. We wanted to give developers a platform powerful enough to run these models locally, yet simple enough to use every day. With 120 gigabytes of unified memory and support for models up to 200 billion parameters, developers can build, test, and iterate locally directly on their desk. Ryzen AI Halo embodies the future of personal AI for everyone, a future that shortens the distance between an idea and a working model. For developers, that means a dramatically more efficient optimized path from experimentation to deployment.
Companies concerned
And
about
as Andy showed earlier, Rock'em.ai is making hardware programming radically more accessible. Developers can understand, modify, and optimize code for Rock'em.
Sorry,
even
you have to repeat that question or maybe lower the volume a little bit.
Let me lower the volume and then you can hear it. All right.
With local AI, the point is that companies concerned more about sovereignty and privacy issues, regulatory issues, and they work more or vote more for them.
AMD compute platform without rebuilding.
Yeah, I think with local, like kind of you basically are training your language model. Right. Like I said, the biggest one that you could probably do on your kind of consumer hardware, like these little boxes are on the hundreds of billions.
Wait a minute, how did that happen?
I did it.
Oh, I know I did it.
Together, AMD and Hugging Face.
Where is he?
Halo optimized performance.
He's napping in the chair.
Models and agentic workflows.
He's right here.
How cool is that? And along with,
I think in terms of like
designed to help developers.
I like that.
Configuring infrastructure and more time building. And
like I would say,
Halo box will include a full year. Hugging Face.
Now, wait a minute. Now I guess Andrew can watch because now Patrick is on stage.
Freedom and more power to the user. This is how we accelerate.
All right, I actually like this part of this presentation, but I'm really hoping he wraps it up. That it's really interesting because I've been looking at this local AI stuff for a while and thinking about buying one of those Mac Studios.
Yeah.
But okay, so that's their little local AI machine.
Yeah, so the Mac Studio will probably allow you to run a, hundreds of billion parameter.
Yeah, beefier language model.
Hundreds of billion, but still, you're not going to get to the trillion. Yeah.
Not unless you're willing to pay like $50,000. But I'm not.
This is no longer limited to a single platform form factor. Together with the world's leading OEMs, AMD now powers the broadest portfolio of personal AI systems.
See, once again, this is the Apple phone versus Android. Android people love to be able to customize. Apple phone people are like, I just want an easy experience. I think you're gonna see the same with this. I know Apple has Mac Studio, NVIDIA has their machine, and now these guys are gonna come out and have the more open kind of technology architecture. So
software stack is open and ready. In open harnesses like Lemonade Server can route workloads to the right model and right compute. The technology is here. The next challenge is taking it from one developer's desk to thousands of users across an enterprise. Cisco sees and believes in that future the same way.
Now we got Cisco coming on.
Deeper into how we turn that vision into enterprise scale.
This gets back to what you've been kind of saying all along, though, Brent. Like nobody's answer. Every claim is like a ratio, right? 30% more token per dollar, right? This and that. No one's giving a number like a CFO can actually plan against you.
Congratulations. Thank you.
He must have borrowed Jensen's jacket there.
Or he bought it.
not from Jensen though.
No, did you see the Sotheby's? What it sold for?
How much?
960,000.
Well, firstly, it's a really exciting.
A jacket that he wore
for his leather jacket. Yeah.
Wow, that's crazy. Oh, this is all right. This is a good part for me to plug. So this gentleman right here, G2 Patel. He's actually going to be on with Fast Forward with Ron Miller. Is really? August 20th edition of that. Really cool. I didn't know who this guy was, but I saw that name. I was like, oh, that's cool. All right, I got to listen now.
Yeah, G2's cool.
Oh, you've
I've heard him before. Yeah, he's cool.
Cool. All right.
So as you start to see this, what you're going to have is a tremendous amount of and there's two big concerns.
Oh, I also have a couple very small amount of shares in Cisco too.
Every customer. So what you're starting to see happen is inferencing is not just going to be limited to the data center. Inferencing is going to be distributed everywhere, and there's a whole new class of computing that's emerging with this desk-side computing that you just announced, where there's going to be inferencing that you're going to have a laptop or a desktop where humans work, and they might have a desk-side computer where agents are kind of going out and running their jobs on behalf of humans. So that's what we're seeing essentially.
On we're fully aligned G2, and that's exactly the shift we're seeing. If AI is moving closer to employees, compute has to move closer as well, right? The PC is not only just a productivity device, because the intelligence node in the enterprise, but deploying intelligence everywhere creates a new job for CIOs that you and I talk about so much.
We do. Yeah.
How do you operate thousands of these systems with security, governance, and control enterprises require? G2, how is AMD and Cisco solving this, and what are we building together?
Yeah, so this is an exciting time because what you're starting to see is,
man, he's black from head to toe in terms of the shoes are shiny black, black jeans.
He's coordinating that.
He is the man in black. He's like Johnny Cash style here.
And so there's a few things that are really important. Number one, you have to have an appropriate amount of network bandwidth to satiate the needs of the agents that you're going to run locally. So this notion of network infrastructure that can get modernized to keep up with the needs that you're going to go out and generate is going to be very important. That's number one. Number two, like I said, every customer is really worried about token costs. And so we need to make sure that we can actually contain the costs of an agent's consumption of tokens when it actually starts to go awry.
Up and down when needed.
Exactly. Number three then is how do we monitor agent behavior for safety and security so that if it does start to do things that we don't want it to do, we can in runtime provide enforcement guardrails. And then fourthly, It's just the overall safety and security that you need to have from an apparatus perspective to get this entire thing humming in the way that you want it to.
Yes, Jeet, it's good how you and I think very alike. So, I mean, the opportunity is not just being at every device, as you and I talk. How do we enable enterprise to deploy, manage, and scale out with confidence? Why don't we take a look at what we've been building the past few weeks and months?
Yeah, it's exciting. So basically what we've done is there's a full stack that you can start to think about. So what you folks have done with Halo is you've got an isolated secure agent sandbox, you've got intelligent routing, you've got an MCP, core set of integrations. And then what we've done above that is we've made sure that you have the right level of security policy enforcement. We've also got the right level of observability so that it's an end-to-end resilient infrastructure stack. So it's observability of how is your apparatus and the infrastructure working. Is the agent behavior being done in the right way? Can you observe the agent behavior? And are the tokenomics within the guidelines that you want them to be? And then what we have is a single unified management plane, a control plane, that can look at every single dimension that you have and be managed within one environment. And so that's kind of the full stack, and we're really, really excited about the partnership.
Well, us too. Our teams love working with your team. Yeah. How's this all managed? How does the CEO deploy this at scale?
Yeah, so let's take a look at what this looks like, right? Because what we would have is, this is Cisco Cloud Control, which is the overall management plane. So if you happen to have, Halo devices on every desktop, which it might actually get to, what you want to make sure that you do is you are able to go out and manage your entire estate of not just your Halo fleet, but also what do you have running on the data centers as well as what you have running in the cloud. So you can provide full visibility for that entirety of the estate. And then once you've got that, what we also have is this notion of how do we go out and monitor tokenomics. And so is the agent behaving the way that it's behaving?
Thanks for singing that, Rebecca.
Is the agent actually going out and being overly consumptive? At which point you should be able to isolate any individual Halo device so that you can make sure that you can quarantine it.
No, I love this. Then we can actually see the return on invested capital. It could pay for itself in 3 or 6 months, even quicker.
Exactly. So what you see over here basically is you can
tell
how every single agent is performing and whether or not they're consuming way too much kind of token costs. And if they are, how do you actually contain the costs as you're going through it?
No, I love this, G2. Now, everyone else is wondering, when can they buy this?
Yeah.
When is this open for everyone?
What's the good news is you can buy the Halo already today.
Yes.
And then what we're doing is we're making sure that we provide this entire management apparatus that's currently in early availability for a select set of customers, but we'll have it in general availability in the US in early fall. So we're excited to make sure
not that far away.
Not just the compute, but all of the apparatus that's needed to go out and manage this so that you can have inference running in the cloud, you can have inference running in your data center privately, or you can have inference running on your desk side.
We're so grateful for our partnership with you and Cisco. We're so excited.
Thank you so much.
And if you want to hear more from G2, you can check him out on Fast Forward coming up on August 20th. There you go.
Well played, Brent. Well played.
There you go. Got to get that plug in there.
But in the age of AI, intelligence will be pervasive. It'll be everywhere. The next frontier is where AI leaves the screen, enters the world.
Physical AI now, I guess.
That frontier is physical AI.
Damn.
The ultimate application of agentic frameworks. In the digital world, an agent plans and completes a task. In the physical
I will say this.
You must also sense motion.
Jensen was talking about this at his GTC in 2025.
Intelligence does not just produce an answer, it produces an action. When answers become actions, latency becomes safety, and reliability becomes trust. That is why the promise of
what he said becomes safety.
Is now about
It sounded like
potential.
Lazy becomes safety. I didn't quite get that one.
Keeping people out of harm's way.
Latency. Maybe?
Is that what he said? I thought he said lazy too, but maybe it was latency. I don't know.
Yeah, I thought he's. Yeah, maybe. I thought like if you're lazy, then yeah, it could be very dangerous. It's not safety. It's the opposite of safety.
Capabilities that robotics depend on.
And reliability is trust. Yeah. So if you're not
That one
reliable,
made sense to me. I just
yeah, that one. Yeah, the lazy becomes safety was. I think it was. I didn't. I think I thought it meant opposite of that.
Coming alive in extraordinary ways. These are not machines.
As a lazy becomes the risk.
They are beginning to perceive the world, reason through uncertainty, and act with purpose. The promise of physical AI already in motion. The next era of robotics is not programmed. It is autonomous. While traditional robots execute instructions, autonomous robots are given an objective.
I remember being in those big crowds we're holding up the phone and taking the pictures and all that.
Of the slide.
Yeah.
Robot must orchestrate intelligence, motion, and safety continuously, and every part must respond at the speed of the world around it. That demands an entirely new kind of robotics brain. And to solve that, we rethought its architecture from the ground up. Today, I'm so excited to introduce the AMD Kria AI system on module powered by Ryzen AI embedded X100.
What the hell did he just say?
Just a name.
Jesus.
GPU.
It's just a name. It's just a name.
Memory together in one
AMD Kria.
standard architecture. This
Yeah, but it's interesting what Cisco G2 was saying though. To your point earlier, Brent, about how do you sort of monitor the cost? If what they're saying is you can sort of monitor agent behavior and then curb costs that way, that could be an interesting approach.
Yeah. NVIDIA Jensen Thor.
Yeah, and I think that is what a lot of the model routing, services provide, right? They will essentially monitor the task, the type of task, the workload that the agent is actually performing, and then route it to different type of model, right? And if you are trying to use it to write code, then I'll route you to Claude. If you try to draft an email, then you probably even a no-name kind of Mistral or some lower cost model will be plenty sufficient.
Today,
even
we're introducing
so they would just
Kria AI
they will route the task to the proper model.
Right? Model routing, yeah, gotcha.
The industry's first turnkey, open, fully integrated robotic system.
Wow.
Thank you, Laura, so much.
Some of this stuff is kind of hard to wrap your head around. At least right now. Especially when you're 2 hours in. It's real hard to wrap your head around it.
This platform gives developers everything they need to move from concept to prototype in days. And the same module carries forward into production with no migration or redesign needed at the finish line. You can build.
Speaking of finish line there, buddy.
Wrap that up.
Yep, it's time to wrap it up.
Only AMD can bring to autonomous robotics. From the first signal to the final motion. AMD Kria for the brain. Versal for the spine. Zinc for the joints.
Damn.
And Spartan for the sensors. Each layer purpose-built for its role. Working together in one intelligent system. Connecting perception and high-level reasoning to real-time control. The future will not be defined by one model, one machine, or one company, but will be built in the open across silicon, software.
This will definitely be a refrain, though. This
ecosystem moving forward together, from the cloud to the
they are repetitive and hitting that message pretty hard.
Compute foundation for intelligence everywhere.
The mantra, if you will.
We're laser focused on the future.
There he is.
Augment and expand what people are
The flexible challenger. Open architecture versus
open.
Yeah, I think strategically that makes perfect sense, though. I mean, if you are the leader, right, you probably don't want to open source. But if you are,
thank goodness Lisa's back. This must mean we're coming to the end.
Yeah, if you're not the leader, if you're the second, then it makes perfect sense to open source because you could grow and expand your your users and contributors a lot faster.
Yeah. I mean, what is he? I mean, to me, AMD is just giving you reasons to not choose them. You know,
Yeah.
From NVIDIA, and I get it.
They have to go that way. It's like Android versus Apple, or you know.
Giving you a preview of what we're working on.
They're trying to take away all the excuses.
In 2028, we're going to introduce Florence. Florence brings the next gen Zen 7 cores. It's leading edge process technology. It's a new set of AI compute extensions to really ensure that we have all of the AI capability, and it supports the latest memory technologies. And we're not stopping there. We're already deep in development of Ravenna, our 8th generation EPYC family built on Zen 8. And that family is already well under development for 2030.
Damn. Okay. What? Can we just get through where we are right now?
It's again going to extend.
Yeah.
2030.
It's all about product breadth and having the right foundation and also the right family for
your question still goes unanswered, though, Brent.
Yeah. But they're not alone. Nobody else has touched that.
That is optimized for these different workloads. That's giving the customers the right
Ferrara
for every workload, and that is our commitment with EPYC. Now, moving to Instinct. We are continuing our cadence of delivering a new generation every single year. MI500 brings next generation HBM. It brings a larger scale-up domain because scaling is everything, and it introduced new copper and optical interconnects. And with MI600, it's powered by our CDNA Next architecture, and it's already deep in development for 2028. Now, to give you an idea of what we see from a performance standpoint, every generation of Instinct has delivered a major big step up in performance. And with MI455, we've talked a lot about it, delivering 35 times more inference throughput compared to MI355. But we're really, really excited about MI500.
Damn.
What we see is another opportunity to take a major step up and actually bend the curve again. So MI500 will deliver the largest generational leap in the history of Instinct, putting us on track to deliver more than 2,000 times higher inference throughput in just 4 years.
These numbers just start sounding cartoonish after a while.
Now, what I can tell you is we are working with a number of our customers already on this design point. MI500 is super exciting, and the feedback we're getting from customers is just fantastic. Now, put the CPU, GPU, and the networking roadmaps together, and you can now see a complete cadence of our rack scale systems. So you should expect from AMD a new Helios system every year, delivering more performance, more capacity so that we can run larger models, more agents at better total cost of ownership. And that gives our customers the complete predictable roadmap to plan and scale their infrastructure for years to come. So lots of exciting things in store over the next few years. So with that, let me wrap this up for this morning. Today, I hope you saw
Brent,
a little bit
you should be happy.
How we're really looking at.
I'm still waiting to hear goodbye. Enjoy the show.
Yes.
We're talking about Helios or MI455 or Venice for the world's largest AI systems. Or you're talking about MI430 and MI350 for sovereign and enterprise AI. You saw the passion in Boxy with ROCm AI. It's so good to see how much has come through that platform in terms of making developers, make it much, much easier for developers to access the AMD platform. And then, Jack talked about Gorgon Halo and our new Kria AI platforms, really bringing together the leadership of the end-to-end AI story, including PCs and physical AI. So lots of new information, but I want to say a very, very special thank you to all of our partners who joined us today, because it is really through those partnerships that we're able to do the most amazing things together. So if I just leave you with a final thought, when I think about where AI is today, the biggest change that we see is we're no longer talking about what might be possible. We're actually seeing how AI can have real and significant impact across every industry and every part of our lives, our personal lives. And I have to say that I've spent my entire career in tech believing that high performance computing can make the world an incredibly better place. And I have never, ever believed that more than I do today. At AMD, what we're focused on is building the technology, the roadmaps, and the partnerships. And there's never been a more exciting moment than today for our 30,000 plus engineers. This is really the next phase of AI. This is where we make AI, give the AI the opportunity with all the tools and all the capabilities to really bring meaningful real world impact. And I can tell you, I could not be more excited to build all of that together with you, our ecosystem. Thank you so much for joining us today.
All right, let's see, that clocked in at about an hour and 15 minutes. I guess it wasn't. Wait a minute.
No.
2 hours and 15 minutes. What the hell am I talking about? All right, let's get rid of this. I can end this here. All right, we made it. That was definitely a little longer. Well, a lot longer than I was expecting. So let's go around and just give our first or final impressions or whatever you want to call it. Let's go with you, Michael, since you are our hardcore AI person. Tell us what your thoughts are about what you heard.
Yeah, I definitely think the advancement is impressive. I mean, I think chips, there's just so much. I think it's kind of not unexpected, right? With so much money pouring into all this hardware development, that they're seeing, they're taking a lot of those money and turn them into innovation and things. So yeah, very impressive. But I do think that it will take some kind of, I would say, it would take a while to translate into the layer that we're dealing with. Right? This is very low level, right? It's just like, okay, I'm making this molecule in your body function much more efficient, right? How is it going to make my entire body, better? That's going to be a few, it's going to translate how the cell is going to work better, or how the organ is going to work better, and then eventually how my body system is going to work better. So it will take several layers before that translates to kind of the layer that we are focused on, we're dealing with. Yeah, unless you decide to kind of go down to the bottom, right, and actually use those hardware to train your own model.
Rebecca, what do you think?
I think there's a very small subset of organizations in the world today who are going to be long-term in the market to build and train their own models. The maintenance alone, never mind the initial expertise to get it up and running, is going to be really tough. I thought it was interesting sort of thinking about the shift in the market for AI inference versus training. So I think that'll be something very, very interesting to track. And I think the final note, I think if we were playing a drinking game, if we had said we were going to drink every time somebody said open, we would all be swearing our words right now.
Oh, yeah.
All right, DJ Wiz.
Oh, man, yeah. Open, better than closed. I think, like I said before, I think AMD's job today was to try to remove all the excuses, why you shouldn't switch to them. And I love the Cisco part, though, because that sort of, began to get to removing the operational reasons, why not as well, too. You're talking about sovereignty and not being able to sort of, move all this stuff onto your, device locally, the edge and so forth. But they still didn't answer your question, Brent. There's still an absolute number a CFO can budget against. So that's the gap I think they have to close next.
Yeah. I first of all, I really appreciate how Lisa presented all of this.
Yeah.
She did a great job. And she did it with like, it felt like at ease. Like that stuff just rolled out of her tongue without her like having to read a script, or she had the command of every aspect of the information she presented, which was really, really important to do. But yeah, I still feel like as much and as interesting and as great the possibilities are with what they're working on, and the partnerships that they were kind of dug into, I still think, and it's not just specific to them. I just think that hearing all that is great, but if you don't give some tangible understanding of what it's going to cost or how long is it going to take for me to get to that, and what is it going to cost us, it still feels very far out and very unreachable. And I'm laboring on the part about the cost, or when will we see this take place, and how long will it take for us to be able to recoup this? As magnificent as some of this stuff is, it's all about the budget and the ROI, and when we'll be able to see that return happening. If we can't get to a point where we're talking, really being able to have a plain conversation around that in this current environment where AI anxiety is just rampant, and the FOMO, as someone says, is rampant, and I think the fear of missing out. Rebecca, your last crunch, I thought it was really interesting because you guys were. What was that? It was something versus FOMO that was.
It was certainty. It was COMO, certainty of missing out versus FOMO, fear of missing out.
Yeah, I actually kind of like that bit of a framing, because the fear of missing out, I don't know if it is being met yet by the certainty of. I mean, the fear of missing up is not really, I think, being taken too seriously on the certainty of missing out, because certainty of missing out means I'm certain I'm going to miss out on a big bill, and I'm not totally understanding how that aspect of it is going to play into me messing up. I'd rather miss out than mess up at this point, I guess.
Because after run, but this has been great.
Yeah. So I mean, I thought all in all it was interesting. I don't think we need to be doing this with AMD right now, because as Michael said, they're still at layers. We can't even see the layers that they're talking about.
Far too many layers below. I mean, I think in terms of ROI, I don't even think they would, we're not the buyer. So they're not going to present an ROI case for us. They will do that for Anthropic, for OpenAI, for the people who's going to train model and run inference, who's going to use their hardware. They would do the ROI for them, but not for us.
Well, but hardware itself isn't going to deliver ROI. Right. It doesn't work that way, right?
Right. Mm-hmm. It's up to the vendors to figure this out, to figure out how to answer that question, even if they have to partner with these guys. But somewhere down the line, somebody's going to have to tell these enterprise customers, when will they see the light at the end of the tunnel when it comes to this? Because right now it's still a very open, and they're just starting to address it at some of these events, but it's going to be harder and harder to get people to do certain things if they don't have a better understanding of where this is going, how long it's going to take for them to get some kind of return. That's what's missing so far in this conversation is that piece. All this other stuff is great, but until you can really tell them how they can do this and what they're going to get back, how long it's going to take for them to get it back, that's tough. It's tough for them to walk too confidently into all this. So, all right. Any last thoughts before we close this one out? We're all just ready for some pizza. That's all. All right. Well,
all right.
Thanks to you guys for doing this. This is a kind of a last minute thing. It was interesting. Like I said, I don't feel like we need to dig that deep in some of this, especially when we have a whole bunch of our industry conferences coming up after Labor Day. So we'll be pretty busy with that. But it was interesting, and I did learn a lot, but I still did learn some of the important things. All right. Have a great rest of the day, and you will see CRM Players next Thursday. We're not doing a show right now because this was it. And then Tuesday noon, the crunch. giving us what end of the summer theme, right?
That's right.
Cool. And then we will probably be doing taking the lid off of AI next week, since we did a special. We really took the lid off AI here. So we will see you next week. Have a good one.
See you. Thank you.